the key idea behind their startups and their business model. And after that, we'll have a number of questions. And I think you also have the opportunity to ask questions after the talks. So let's start in the order of appearance on the agenda. So Ubika will go first. Do you need this?
I guess. Thanks, Holder. Hi, my name is Georg Bartels. I'm one of the co-founders of Ubika Robotics, and this is the button, right? Cool. And yeah, I'm going to quickly introduce what we do. So we build mobile scanning robots, autonomous scanning robots for brick and mortar retail stores. Robots such as this that drive through supermarkets, home improvement stores, pharmacies at night after the shops close, and they take pictures of the shelves, of the furnitures, of the products that are all mounted on a rigid axis, and the device afterwards computes using classical computer vision technology, but also machine learning technology, what it has seen while it drove through the store to build a representation that we call the digital twin. And that digital twin is then uploaded to the IT systems of the retailers. Here you see a representation of the digital twin. Actually, those videos, now they work. Yeah, cool. I'm supposed to show you roughly what the digital twin is. You can envision it on one hand like a computer game world. You can load it in a rendering engine, walk through it, look at things, and things will look like you would expect them. Here you see one shelf, maybe with a little bit of noise on it, but then on top of that, it's an information processing system, a database that you can ask questions to. And those questions, or specifically the answers, is what actually our customers, the retailers, want. We originate from Michael's lab. All the work is based on basically the results of a European Union funded project called Refills, which finished a couple of years ago, and then we went through an Exist-Forschungstransfer to get the company up and running, and now we are financing ourselves with external money. And here, a quick view at what are the types of queries in German that our customers might use in some applications. They vary through a lot of stakeholders, people that are actually in the store, from what is the shortest path to collecting a click and collect order for clerks to, hey, where are the products of a certain supplier, maybe in this case Ferrero, are placed in the store to check compliance with contracts. Where do I have out-of-shelf situations for particular products, for maybe prioritizing restocking or automated rebuying of products, to where do I find a particular product like organic hummus in the store, which is something that the actual customers of the store might ask while shopping. So this is to outline that the business model actually has two parts, two products: the physical one, the robot that is the measuring device, and the data in the end that we put, which is the thing generating the value. So the company basically has one leg in the real world and one leg in the virtual one. Okay, so much for us. I'm looking forward to the discussion.
I think you can immediately hand over to that.
Thank you. To plug that in. Okay, good morning everybody, and thanks for the invitation. For those, okay, that looks better. For those who don't know me, my name is Daniel. I did my PhD here in Michael's lab, and I'm still a researcher and lecturer at the University of Bremen here. And last year in 2021, I had the privilege to co-found a new startup in the context of the Team Neuster company. So for those who don't know, Team Neuster It's one of the biggest IT companies here in northern Germany, with more than 1,300 employees, and which is organized in almost 30 sub-companies. And we founded a new company, Neuster Data Intelligence, last year. So what are we doing? We help our customers to perform better in highly intransparent markets, and we do that by building AI systems that autonomously generate new insights from large amounts of data and derive evidence-based business decisions. So this is not a robotics startup in the narrow sense, but it can be considered an AI startup in the broader sense, because we also develop AI agents that act in an environment. They perceive the environment by data, and they learn from experience to get better and better. Let me give you an example. Consider, for instance, the tourism industry, and in that market, there are a lot of players that interact directly or indirectly. For instance, there is tour operators like TUI or DER, and there are many, many more. There are also cruise lines, there are airlines, there are obviously airports, there are destinations, there are travel agencies, online travel agencies, hotels and hotel chains, and last but not least, the end customer. And all those players, they interact with each other directly or indirectly in that market. And while doing so, they produce data, and they produce massive amounts of data. As an example, in 2019, we received, for instance, almost 11 billion booking requests per day. A booking request is something that when you go on the internet and you look for a tour, let's say, I want to go to Mallorca for 2 weeks, then a booking request is issued to some booking engine and creates such a booking request. And so this is really lots of data, and it's challenging to analyze these things. And what we're doing is we correlate these market data with social media data, with media data, like for instance, the Mediatheken from the German public TV, but also social media, because these data allow us to predict how markets develop in the future. For instance, last year, when Angela Merkel said that they will stop like the travel warning to Mallorca, you could see an immediate pop for the booking requests to Mallorca, right? So while skimming through these data, you can analyze and detect trends and do quicker and better business decisions, like forecasting, better dynamic pricing decisions. We can do trend detections and also make recommendations for new products. And we offer that as a software as a service for those market players that I just mentioned. And yeah, this is our Neuster Data Intelligence startup. Thanks.
So, also from, no, that's not me. This is you.
Thanks. Thank you very much. Very happy to be here. I just came from Karlsruhe with the night train. Was exciting. So yeah, my name is Darko Katic. I'm from Artimind, and we are in the business of, how do I change the slides? The yellow one, perfect, thanks. We are in the business of creating software to facilitate programming, planning, and analysis and optimization of industrial robot arms for manufacturing purposes. We are from Karlsruhe, from the Karlsruhe Institute of Technology, the KIT originally. We are quite old for a startup, founded in 2013. And we've basically developed two software suites. One is the Robot Programming Suite, the RPS, which is a software solution, a low-code solution, so you can program your industrial robot arms without having to be a software engineer. And we have the Learning Analytics for Robots, the LRR, which allows you to optimize and analyze your robot data without having to be a data scientist. So the basic idea is to make these things a lot simpler than they are now, and also to be independent of the use of the underlying robot hardware. So we are supporting, the usual suspects, Universal Robots, KUKA, Yaskawa, Denso, Fanuc. They can all be programmed in the same way that it is more applicable to the ways engineers think and not so much information scientists. What we're also doing is a lot of customer projects. This is an example. It's not an original customer project because of NDAs, of course, but that's a general idea. So we are focusing on advanced robotics. You can also use us, of course, for simple pick-and-place applications or machine tending. But where we shine is advanced robotics. Advanced robotics for us is things that require some sort of dexterity, flexible parts, non-rigid bodies, things that need some kind of perception, in this case force torque sensing, but of course also vision. Actually a lot of force torque sensing, because vision is sometimes not wanted in the factories because of simple things like you have to keep them clean, they cost money, you have to calibrate them. So this tactile feeling can solve a lot of problems and with a very industry-friendly way, let's say. And apart from the projects we do with industrial partners, we also have an innovation lab, which I'm leading. This is where we basically use public funding projects to basically do our pre-development. So all the things that are in the software, maybe in 2 years, 3 years, 5 years from now, is being developed pre-developed in the innovation lab. For this, we have a lot of cooperations with research institutes and industrial partners, of course, also with the University of Bremen. And I would love to talk about all the projects we have and all the interesting things, because this is not NDA, so I can talk about it freely. But for today, I decided to talk a little bit about the topic of how do we do the transfer. Like, we came from the university, a lot of our people have PhDs, and how did we get to the point where we are an actual industrial company. And the mindset that worked really well for the innovation lab, but also for the entirety of Artimind. I tried to summarize this a little bit. Actually, the first one is the toughest part. We are always prepared to let ideas go. Like researchers, they fall in love with their algorithms, with their ideas, with their vision, and this is all great. But sometimes it just doesn't fit the problem, it doesn't fit the requirements, it doesn't fit in the industry you're working on, and then you have to let the ideas die. And this is painful, but it's an absolutely necessary step. One of the founders, he said one of his greatest achievements with the company was not doing what he did in his PhD. Or it was a great PhD, but it was not industrial strength. So this basically ties into the second thing. Like, there are things you really want to do because you're fascinated by them, and there are things that are feasible, and there are things that are actually useful. And these three things are unfortunately not always congruent. It's also important to have a really good vision, but I've seen a lot of people that lose themselves in their vision, like the German saying, you don't see the forest because of all the trees. People are building pies in the sky, they're over-promising, which is also dangerous in the industrial setting because it catches up to you. So it's important to have a vision, but it's also it's maybe even more important to get the details right, to actually make it work, to make it robust, to make it user-friendly. A Python script is great, but that's not a company. So a lot of work and effort goes on the accessories, things that in PhD you just can skim over, but it switches, like 90% of the work is getting the details right. Of course, connections to academia is very important, and what Professor Beetz said earlier, that's basically this I call it embracing interdisciplinarity. So we are working with a lot of different people. We are working with the workers that actually use the robots. We are working with civil engineers. We are using unorthodox workpieces. We are even having medical robotics projects. It is not our main commercial goal, just to have more input from the other side. You know, when I began studying, or when I began even my PhD, I was thinking like, you know, innovation comes from you know, a person sitting in the lab and having great ideas and these eureka moments. But the more I'm in the business, the more my opinion is that innovation comes from connection. Like, you have to talk to people, you have to get inspired by people, you have to build on the ideas of others. Like, the times of Archimedes and Galileo are over, everything is interconnected, and innovation comes from connection. You know, great ideas come from great minds meeting, and that's why I'm so happy to be here today. Thanks.
And I hope that now is really my turn. So, my name is Claudio Riarte. I'm a CTO and co-founder of Cellumation, and I'm really happy to be here. Thank you very much here for the invitation. And yeah, I would like to show you a little bit of what we're doing. So if you, from the technical side, we're solving multi-agent path planning, path execution, collision-free execution of a very highly over-determined system. But in short, we're moving parcels. So where the idea comes from, it comes from turning robots upside down. And this was our eureka moment in during the development of the system, which started about 10 years ago in the neighbor institute BIBA, also at the University of Bremen. So why did we came to this solution, or how did we find the problem? So the BIBA is a research institute in the area of production and logistics, and in logistics, you move things around. And if you take a look on how this had been done for the last over 100 years, it started in the 19s with the roller conveyors. In the 1920s, you came to see the motorized roller conveyors, so you could move things up and down, and today it looks basically the same. We have, the systems have been getting more complex in this in performing the different applications, but the basic concept of the roller moving the objects around and having this type of elements to change the direction has remained the same since then. You have a lot of IT on the background, but from the mechanical side, it looks the same. So this is restricting growth on the companies doing logistics. So the idea, as I said, came from highly scientific research in YouTube. I was bored looking at YouTube videos, and I saw these small robots moving around. They're well known here in this circle, football robots, and the idea was to see what would happen if we turned them upside down, and we would move the football field with the wheels. So this is what we did, and it actually worked. That was about 10 years ago, and then we started building different prototypes with support of different ministries, German ministries. So what could we do with our system? This is basically the cell that we have. It's an inverted omnidirectional robot with 3 omni wheels, each wheel driven individually. And we put all these robots together, but the cell itself doesn't have any function. The function comes with the software. So depending on the software that we put on this machine, we can make it from a singulator, we can make a depalletizer, a sorter, or any application that we can think of in the intralogistics where objects are moving in 2 directions. And what are we actually, how does it look like? This is as I said, the problem of multi-agent path planning, path execution. It looks like this. We have boxes entering our system, and in this case, we are reading, we can read some barcodes, or we can detect some properties of the objects using 3D vision or barcodes. And we can decide if the boxes are going to move straight or if they're going to cross the field. This is, allows us to create completely new applications that in logistics they're not known until now. Another application that we have is depalletizing. In depalletizing, we receive a layer of a pallet. It is provided by a robot, which is not our job. We're doing all of the conveyors here. And when the layer goes into the system, we detect with our vision, we detect the position of the parcels. Then we calculate a path, collision-free path, and we execute them on the spot. If we would drop a parcel into the system on the fly while flying, we would detect this parcel, and when it lands on the table, we would have a valid collision-free path for moving this box out of the system. So it's, I said before, it's a really complicated, lots of hardware and software-based company that we have, and this is what makes it difficult. It's we have to compete with existing companies. We need to to compete with existing technologies, and this makes it difficult to go into the market. Difficult to get the first customers, which we could get about 3 years ago, and they're finally giving us the go to make marketing videos after they've seen that the technology is working and they didn't make a big mistake with us. So 3 years without a single failure, I think it's something you can talk about. And if there are questions here, I'd be happy to tell you a little bit more about us.
Thanks a lot to all of you for presenting all these interesting projects. Dr. Kartic, will you join the panel, please? So I'm going to ask a number of questions and ask everyone to answer them, and then I'll hand over to the audience to also follow up on maybe your answers or the questions. So, and I think all the ideas we've seen here are great ideas and great solutions, and this is certainly a prerequisite to have a successful startup. But I'm wondering what you think is a key factor, maybe on top of the great ideas, to have the startup becoming successful.
For us, it certainly has been focusing on what the customers want, what the market wants, and really following that advice. Because what does that practically mean for us? Looking at not only the features that we need to do in software, but actually how does the hardware have to look like in terms of what can it cost, how big can it be? Because the hardware development for us, it takes a long time, and if you commit to the wrong things, then you learn 2 years later that this is impeding your sales. So for us, it has been very important to very quickly get to know definitely the hardware. How do we have to design the system such that it is practical and can be sold at a reasonable price?
I think it's pretty simple and hard at the same time, because in the end you need to solve a problem of your customer, right? And this sounds easy, but if the solution for your product is in the end cheaper than the value that the customer gains from it, then it will work, right? So the investment must be smaller than the revenue that you get for the customer. And I think this is, it's a simple equation, but it's of course hard to achieve in the end, in particular in B2B businesses, right? Where it's in the end a calculation of is it profitable, a profitable invest or not, your product, right? And I think this is one thing that you really have to consider from the very start.
Thank you. I think from from my point of view, or from what we've learned in Cellumation the last years, there's different, depending on the stage where you are, different points are important. When you're beginning, let's say as a researcher, then you need to have a really good idea where you can convince your professor to let you ask for funding in a project. On the second stage, you need to have support to get this idea running. We had the support from different ministries. We had support here from the Exist program, which allowed us to get the system, the company running. After when you are founding the company, you need to have the right co-founders. The wrong people will lead you to a miss success. And then you're already just starting. You have founded the company, and then you need to find a team. So if the team is not pulling on the same rope with you, then you're going to land somewhere which is not where you want to be in the next 5 years. And we have different ups and downs, and we have found with a lot of trial and error how to find this point. And yeah, I think that would be from our side. And of course to have some investors that support you. If they pull the plug too early, or they're becoming very, they want to get return immediately, very fast, then you have a big problem. So if you're going to found a company, pick your investors very good. Don't let them pick you, you pick them.
Absolutely great points, yeah. From our side, maybe as an addition, what also surprised me personally is building trust. Like coming from an academic background, you're used to people, you know, being excited about new ideas, being supportive of new ideas, being very experimental. And then moving into the manufacturing industry, like these people are very cautious. And they are very cautious for a very good reason, because, you know, they're pumping out thousands of parts per day. And if the machine stops for like 5 minutes, they are losing a lot of money. And they're very cautious, and they're very well prepared for all the eventualities. And that's why they are also very wary of new technologies. Because, you know, I can tell them, oh yeah, that's worked, that's great, it's fine, I tested it in my lab. That's not good enough. Like this doesn't convince people. And I can totally understand that. Like when we began like years ago, it was a very simple algorithm. It was basically just taking the average of a couple of numbers to do some optimization. And some customers, they really didn't want this. Like they wanted mechanical barriers to make sure that the robot can't physically move out of this region and everything. This has changed. Like, you know, the pressure from what's happening in Ukraine with Corona, you know, people are forced to innovate. That's why they are forced to be more courageous. But still, like this trust issue is a very important one. And, you know, I said a little bit in the talk, this over-promising, which is kind of, you know, you probably all saw the Tesla robot, right? And you know, the marketing in front of it and what actually came out. And this over-promising is very dangerous because it destroys the trust. And it destroys the trust for all of the industry, like not just for your company, but for everybody else. So building trust, understanding the needs of the search, understanding why they can feel angsty, you know, why they are so cautious, what's their actual problem, and then coming from that side and making sure that they feel confident. And, you know, one automobile OEM, he told me, if he doesn't understand it, it won't come into his shop floor. And this is a very reasonable. That's also what the surgeons told us. If they don't understand it, it's not being used. So this whole explainable AI is not just an add-on. It's very important. And even even simpler stuff for academia, you know, decade-old stuff, still needs a lot of convincing and a lot of proof that it's actually doing what it's doing. And I think if you don't do this correctly, people won't trust you and then won't use you, no matter how great it is and no matter how great it is in theory.
All right, thanks a lot. Are there any questions following up on this from the audience? Yeah?
I'm just curious, how do you see the funding situation in Germany, or what is your experience? How easy is it to get started?
So we've done a couple of smaller rounds instead of one big one. So we have contact with different investors in different stages of the company. And there's the expression German Angst, and I think it is also in the risk capital, in venture capital. It's very difficult to get money here. And if you go to America, you would get the money a lot easier, but they want you to live there, and that's a problem. So you could get the money there, but then you have to move, and that's in our case, we wanted to stay in Bremen, and for that reason, we let's say probably our financing rounds were a little bit smaller. But everyone agreed to that we could stay here, and in our case, it's very, very important.
That's absolutely also our experience. It's very important to have good investors, but it's very hard to get them. And also, you should look into not having just good ones and not just having people who will give you a lot of money, but who are patient. The markets, it's not like Facebook, things can go viral, but a robot program that can't go viral. This takes time. The market is a lot slower, so you have to have patient people. And in addition to what you said, also people that are very well connected. It's not just someone who's giving you money, it's someone who's giving you contacts, who's giving you customers, who's talking well about you in his circles or her circles. And this is also a major point, at some point, the investors can, well, they're not employees, they're also not co-founders, but they can, in the best case, they can be some sort of part of the team or counselors, advisors, and lead givers. And if you get that right, then you're pretty much golden, but that's difficult to achieve, and it's rare.
I have a question. You mentioned that it's really essential to generate trust from companies who want to use your technology, and you said it's essential to provide some proof. Do the companies support you in providing that proof? Because it must be costly. For instance, if I think of your business model to provide proof to a logistic company that your multiple robots are doing their job, is an incredible expense. Do they help you providing that proof, or is it your Vorleistung? I don't know the English word for it.
So in our case, it's been very difficult. So because the first companies that take the step, they're making a huge risk, and especially the people in the company. It's not only the company, but it's the person in the company who's supporting you. It's taking a big risk inside the company. So they want to make sure that it really works before they communicate that. So at the beginning, you can start with a small project, and then you have the machine running. And if it works, and it takes, let's say the first customers are willing to talk about the project 2 years after we started them. So it's 2 years where you have to keep your mouth shut. You can show images, but never show the logo of the company. And after these 2 years, they say, well, it worked. My boss didn't fire me, so you can talk about it. And that's the point where we are, at least we are right now. So it's starting to we are able to show the logos of the companies that believed in us 2-3 years ago, and that's really important. And this, you have to finance it by yourself. Ideally, so we don't, for example, we don't do test projects where we finance everything. The machines, the customer has to buy the machine, so they're paying for that. But they're paying some with some discount for risks.
You did an excellent job in building up the startup companies, right? But the University of Bremen doesn't have like institutions like Unternehmertum, where basically entrepreneurship is coming into the study program of the students. So you did it despite having that kind of education and training. So how much do you think would it help to have an infrastructure like that and getting an entrepreneurship spirit into the students, right? And kind of giving them some basic training in building business proposal and everything else.
I'm going to take that question. I think it would help a lot. And I want to give a couple of examples. So when we started this year, so it's not like the University of Bremen doesn't have anything to start out, right? So there is Bridge as the network where we took evening courses on getting, you know, the basics of how to make a business plan. That was really good. I think if you mention Unternehmertum, also to relate to the question before with the German financing, I didn't want to take that question because I thought, well, for us, for Ubica, it has worked great, but I don't have so much experience on raising money because, well, it worked great. We managed to do it, but you know, we had Corona. There was a lot of not meetings for the last 2 years, so we went through this dance, and then on top of that, the network that we could build on of people that we know is not so dense here. So it's not that when we started and we grew up, we had a lot of events where we could talk to people and figure out, this is how they did it, those are people to talk to, etc., etc. So I felt like, well, for us personally, we are lacking a bit on just knowing a bit. So what helped us a lot is then to find startups like, talk to Moritz from Magazino, talk to Hendrik from you guys a lot. We talked to Michael Super. Reaching out to others who have made the experience, but then with the exception of Cellomation, they're all not from here. So I feel like that would really help a lot to foster the exchange of experience between the people who want to make startups. Yeah, and the last couple practical thing, just have template contracts for everything. I was surprised how little help we could get from the uni. When it came to making, IP transfer, etc., because it was, some of these things have never been done before, and then you really had to pay the lawyer yourself.
Thank you. Any other questions? All right.
Thank you for the presentations. I have a little follow-up question on the understanding and trust. So what in your experience is, so to say, the typical situation when it comes to companies using AI? To which extent can you build trust by just answering their questions so that they have the feeling to understand because you have some good answers to their questions and nice slides? And to which extent do you just see that you have to simply sign contracts with some liability statements, and for your application areas, what's the state of the art in terms of legislation, standardization? Do you have to deal with that at all? Or is it in the end, if the company has the feeling this makes sense, they just want to understand, want to have a good gut feeling that, the risk is reasonable, or do they strongly look at legislation, liability, and make you sign with blood whatever is in the contract?
So the German industry has been a bit reluctant with respect to AI and automation. In our case, when you want to push AI into actually business decision making, then the biggest factor that creates trust is transparency. And for that, AI systems that are white box systems is extremely important. That, for instance, when you create predictions or inferences for decisions, then no one will trust your system if you have a black box and it just spits you out a number, right? But when the decisions are traceable and you can explain everything, why the system has made a decision, how it comes to that conclusion, this creates the trust. And that helps a lot. And in the end, as I said in the beginning, when you create some value for your customer, then he also has an interest, right, to get the system into deployment. And so I think this is, so both parties have an interest to get the system to a success then, right? So.
I actually think that we all probably have a very different answer to that question. If I think about the products, because with you two, you build machines that do things in the real world. It's very, very clearly obvious when they fuck up. People can point to it and say, hey, that package shouldn't be there or whatsoever. I think with you, it's actually pretty hard. Well, we're saying it's going to be more expensive in Mallorca. We have to wait for that. And then maybe it doesn't happen. And then but the world changed in between. And so it was a good prediction at the time. So for us, it's more like, well, the robot says there was no product, but there was, right? So for us, it's actually a lot we have to go and prove in the ongoing process that the perceptions are correct. But it has to kind of happen at the time, or with samples where you agree and you take ground truth and you do this reliably. And it's much harder after the fact. Because, if after 5 hours people came into the shop, they took the product or somebody replenished, the world has already changed. So their transparency comes in. We have to maybe change the raw data, the pictures, and say, well, but here's the picture that the robot took. But yeah, I actually think it really depends. And if you talk about contracts, at least also for us, when we started thinking about this, well, you very quickly then also have to tell to the customer, well, if you want to cut the bill, if you play this through hypothetically, you have to show us that it was wrong. So for the customer, it's the same problem, which is harder than in your case. So I guess it really depends. But yeah, in principle, I think your answer is also really good that, well, if the value is still there, people will not complain with occasional problems.
And as you said, in our case, we're doing automation, and you can point when the machine is making something wrong. But for us to build trust, it was very important to get the first customers. And there our investor played a key role. That's a system integrator from Spain. And they brought a lot of customers with them. And then we see a difference between Spain and Germany. In Germany, everyone wants to have innovation, but you have to prove that it's at least been 10 years in the field and it's not going to make problems. And in Spain, they see the innovation and they say, well, I want it. So it's been a lot easier to work in Spain than to work with companies in Germany. And perhaps it helps a little bit that my mother language is Spanish. So it gives a little bit more trust.
Definitely. Maybe a little bit, like I agree with everything. That's also our experience, maybe a little bit more concrete. Sometimes you have to basically fit into their workflows. Like, we are not usually doing something completely new, but the processes we automate, they are already there. Like it's human beings doing them, or it's very crude machines that don't work well. So it's usually existing programs, and there are already protocols to allow these processes. Like, I don't know the English term, but Abnahmeprotokolle, things that you have to show, and then you're allowed to do it. And this is all in the contracts, because it's suppliers all the way down. Like nobody's doing anything on their own. It's always companies delivering things to other companies, which then build things, which then end up in the consumer product. And they guarantee to their customers, well, we did these kinds of tests, and this came out, and then this gets the approval, and then it's fine. And you have to do this too. Like, even if it doesn't matter if it's AI or if it's some classical thing, if you can prove the same way that you prove that the humans are doing it right, then you're fine. So there are already protocols, but they are not suited for artificial intelligence. So this can be a problem. Like with deep learning, you cannot guarantee a 100% success rate. There's always well, it's just a statistical thing, and that might be difficult. But yeah, usually it's not even that complicated. It's basically they tell you you have 8 hours, you have to build 1,000 parts, and they have to pass the usual quality test, and 2 of them can be faulty. And then you do it like 3 times, and then it's fine. And then it doesn't matter what it actually is. Then you've proven it statistically, basically, with their existing contracts and everything, and this helps a lot.
So we also have Ram in the audience, right? And he actually was a key player in building a startup in the Anglo-Saxon domain, and I think would be interested to hear what your perspective is on some of the questions we had here, and whether there is something we can learn from your side. Yeah. Oh, sorry.
Yeah, so unlike the others, my involvement came about over coffee while I was talking to Michael in the morning. So I've been co-opted at the last minute. So I don't have slides or anything. So maybe in a minute or two, I'll tell you the process that I went through. So as background, I'm a professor in the School of Informatics. So those of you who were here yesterday, you've seen my academic side. But over the past almost 6 years now, I've been involved in a company called 5AI, which is a startup company in the area of autonomous vehicles. It's quite a bit different from the experience of the others you've heard about, in that it was first and foremost founded by serial entrepreneurs who had previous experience in the semiconductor industry. And I got involved because I was on sabbatical thinking about doing my own company, and then through various things that I won't bore you with, I ended up as part of the original team in the company. And so it was not a spin out as such. It was more that I got involved for the expertise that we had developed in my research agenda for a decade before that, which happened to be also the big gap. So the genesis was that I was thinking about interaction and machine learning for interaction in a deep way, which, as we discovered, is one of the key bottlenecks for autonomous vehicles. So you see lots of autonomous vehicle demos. I mean, every university has autonomous vehicle demos. The distinction between that and something that works on the road is that you actually have to cope with normal people on the road. And that barrier, it still remains a barrier. So without boring you with all the technical thing that happened, so I thought there were 3 things. It has had a positive outcome. So earlier this year, this company has been acquired by Bosch, which is a German company, so I'm sure all of you are familiar with. It's been acquired primarily for the technology, so it's been a very good outcome for the investors and for the employees. But I thought I'll leave you with just 3 points of things that I learned, similar to what everybody here has described. It was quite a different company in that it was very much venture capital backed right from the outset, so it didn't go through the university process at all. And as many of you have pointed out, the market is quite a bit different already between UK and Germany and between UK and the US. And so we started out with a US-UK focus, and we engaged with several German investors and other European investors, but ultimately we ended up with a heavy bias towards the UK and US investors. So the lessons that I learned in this process that I thought were interesting is that in order to get started, in order to reach the seed round, your ideas are important. So you have to get credibility in that people must believe that you know something that the others don't easily know. But after that, it's a bit like, in a building like this where everybody has a PhD, your ideas are not the most important thing after that. So, once you're in a group of professors, everybody is a professor. Don't keep talking about that. Then what matters is actually the quality of your team. And if anything, I mean, although I describe it to you as I went with these scientific ideas, most of the actual work I think I did was to put together the engineering organization that then delivered. And that was, in many ways, my most important contribution to the company. And that team actually is backed by things that go beyond the science. So it was extremely important, the first 5 people I recruited. And they had to have this capacity of, I put you on a plane, you will go to the test track, things will go wrong, I don't know what they are, you don't know what they are, but you will fix it in the 3 days and then come back. And you need people like that. And what the university sector can do the most is to create those people. So those of us who do robot demos know this, right? So every difficult robot demo and the overnight experience that you have put in is training for this. And in the process, when you select the few people who have the tenacity and the capacity, then that's why you have the company. And if you don't have it, you don't have a company. You can have all the clever ideas. I still have clever ideas, but only some of my ideas made it into the company. The other thing I realized is that a lot of the actual value in the business, by the time we did many rounds of financing, and I participated in all of them. So the seed round was totally different because you're just trying to show off your science. By the time you get to one of the later rounds, they've trusted all of your science, and they're asking you really hard-nosed questions about, prove to me this is going to be hundreds of millions of revenue, and prove to me this happens. And they're no longer just taking you on faith. And then what I discovered is that a lot of the value lives in kind of ethereal questions like, what will it take for me to prove safety on the road? And how will I kind of translate that? And, for a company like 5AI, the eventual customer is a company like BMW. So they're saying, okay, what will it take for me to convince them to put your piece into their piece? And you realize that it's not just about good motion planning or good SLAM or good this, and many people can do that. It's about translating the reason everybody else is not able to do something like safety or like reliability is that they don't have this piece, and to give a demonstration that you can fill in that blank. And that's something I don't think we get trained enough on, and we learned kind of the hard way, and we learned to make that argument. And I'm sure all of you face exactly this experience when you're doing this. And so just to kind of conclude and give back to everybody else, I recognize the sentiment of every comment that's been made in this panel, and I think it's very similar when we do panels in other places. And the most important thing that I find in terms of inter-country comparison is to kind of realize that ultimately businesses transcend companies in important ways. You might find your customers in a completely different country from where you are. You have to grow where you are, and your people come from where you are, but then you might sell to people that are in completely different places. And so that's both a strength and a weakness in some sense. Thank you.
Thank you. Further questions from the audience? Yeah.
Thank you for a very nice talk. And I want asking about how can I say, correct the peoples, find the good peoples. And in Japan, I think that it's very hard to find the good people for startups because most of the smart guy go to the big companies like Toyota, Nissan, etc. And because of the company has very nice salaries and support, they usually did not quit from such companies. So this is why a lot of startup companies try to recruit the people from the university or laboratories like us. And how do you, so my question is, what is the situation of such human resources for the startups in Germany? And how do you, what is your strategy to build up a good teams? After you collected the 5 first people, but after you have a good success on your first round, then you have to grow up your companies with a very smart people. So how do you find such a people?
So the mic is in front of me, so I can start. We are about 5 years old, and we've grown from 2 guys at the university to 75 people. So we hired quite a few really good people. I would say the first thing is that at the beginning, you tend to try to hire the best developers. And you could fall into a trap and you would hire a brilliant asshole. And this brilliant asshole is going to kill your company. So you have to make sure that the person fits in your spirit and the company spirit. And then, and the second step, he has to or she has to be brilliant. So in ours, right now, what we are doing is that the first interview that we do is to see if the spirit is okay. And then we go into checking if the technical side, or let's say sales side, it's there. So it's fit, and then technical side from our side.
From our side, kind of very similar. We have actually some sort of process for this. So what we are doing is we are trying to catch them early. We are offering a lot of bachelor theses, master theses. We are very close to the Karlsruhe Institute of Technology. Like, you can bike. This was actually a decision to have the company so near to the campus that you can go there by bike. So we are very attractive for students. So we get them early on. We can work with them. We can let them go if things are not going well, because it's normal. Like, after your bachelor thesis, it's normal to go. You do not necessarily to get an offer. And we can get this cultural fit. You know, they are with us like sometimes even for years before they become full-time employees, or at least a couple of months. So this is one option. But the downside of this is, of course, you're only getting junior positions, because they are by definition very young when they come to your company. For the more advanced positions, like I'm not the founder, but I'm the third employee. So. I was there at the very beginning, and of course, it's because I'm so brilliant. No, just kidding. One major reason why I got the position was because I knew the founders. Like, they were the PhD generation, once older than me. So they finished their PhD when I was starting. But they knew me. We've known each other for years. They know how I work. I know how they work. So all this cultural fit was already cleared before that. And a lot of the higher ups that have been hired, in a higher position, they came from the same network. Like, the robotics world is not that huge. People know each other. So this was also a major point in getting more senior people in the company. You just know them from your network. And this is also what helps you with compete with the bigger companies. They're anonymous. It's great if you can work with your friends. Like, that's. The problem is, this is usually not enough, so you still have to do what you basically said. You have to get people from the outside just to get enough people. And it's also, and this is also something quite dangerous, if you rely too much on your own network, you're getting people from the same mindset, and you're getting people from the same education, and you're getting people maybe from the same professor even. And this can give you, a very big bias. So it's also good to get fresh blood from the outside and take the risk of them not being fit for your company, but maybe they cause a little bit of a change in your company, which actually improves it. So it's not good. In German, there's the word Stallgeruch. It's everybody's coming from the same stable. That's also not that healthy.
Yeah, I want to add one thing. Like, all of that is correct, but I also want to resist a bit the notion of you need to have great people, because it kind of classifies people in bad and great, right? Like, and I was actually very much surprised with a lot of people we hired that had made difficult experiences in their career life. So they're not early stage, actually unemployed for a while, that didn't find a niche. But where it was clear that we need them to fill a role that really fits their interests and that they couldn't find somewhere else. In German to say from Weiterbildung, Umschulung, people who have very good skills, but they somehow didn't find the place to fit, and you wouldn't qualify them from the outside as, well, that's the great guy, but they're actually great guys. They just haven't found what to work on. So I think it not always has to be hot shot whatsoever. You really have to look at what are the particular roles that you need, and give people a chance to shine. yeah, and then, I mean, that's also something that as a startup you have to do if you cannot pay so much and you don't have the big brand and everything behind you to, you know, fill the roles.
Thanks a lot. So unfortunately, we have already run over time into the coffee break, so we have to stop the very interesting discussion. I'm sure there are many more questions, and I suggest we just continue discussions in the coffee break. So let's thank our panelists again for this very interesting talk and discussion.
Okay, so let's start with the next panel. So the next panel will be on Eurocore, and Eurocore is a new European network of excellence centers in robotics. It's like the ALICE network in machine learning, but we now managed under the lead of Aline, who is unfortunately sick and cannot be here, but he would have loved to be here. We managed to kind of get that kind of network for the robotics community. And I think for the robotics community, this network is a big opportunity. And I think it's our job to actually kind of make something out of it. And so in the panel, so we have an interesting mixture of people. So we have Radu Rusu, who is also a former doctoral student here, and he was also some of the early and influential people inside Willow Garage. And I said earlier, right, I think that we have to learn from Willow Garage, from the development of the ROS community, kind of to make something out of Eurocore. So he will talk a little bit about how Willow Garage, how kind of the ROS community developed, and give some of his perspectives on that. So then we have Daniel. Daniel is together with Rudolf. They are underneath Aline, and they are the liaison partners for specific areas of Eurocore. So they will kind of give their perspectives, probably also some of their expectations about kind of what Eurocore is supposed. Then we have Luisa Strino. So she's giving a completely different perspective. So she's managing the project Knowledge for Retail. And in Knowledge for Retail, we make an open innovation platform, a digital innovation platform, and we get a community, an ecosystem on the other side with many retailers and organized from ERE, and we have a producer side with Neustar and many of the industrial partner. And the idea of that digital innovation platform is that we at least have reference implementation of some of the key tools as open source. So I think because Eurocore also has to integrate the companies and get out of it, I think we can also profit from some of the lessons and some of the activities we have in Knowledge for Retail, and Luisa will bring that aspect in. Yeah, so cool. Then I think we start with a video of Ratu, who will talk a little bit about how Willow Garage and ROS developed.
Hi everyone. For those that don't know me, my name is Radu Rusu. I am the CEO and co-founder of Fusion, also CEO and president of Open Perception, an organization that actually was created to deal with 3D point cloud processing a while back. I'm also a former student of Michael's, and unfortunately, I apologize I couldn't be with you in person today. I really wanted to be there. Michael really wanted me to sort of like touch base on my experiences with Willow Garage, having had been part of that company, with ROS, with open source, with BCL, all the open source efforts that we had, as well as like how did they contribute towards the wider community, whether it's academia or businesses around the world. I'll take you for a ride through some of the his history as I know it. As some of you that might know me or have followed my career, I actually did start in Munich, being part of like Michael Witz's like PhD group working on 3D perception, so point cloud processing for robots. I did have the opportunity to end up at Willow Garage first as an intern, visiting researcher, and then later as an employee, leading their efforts for 3D computer vision. Willow Garage, it was very interesting, and I think it's going to go down in the history of robotics as like a very impressive, as well as, again, as I said, interesting experiment. For those that don't know, from my perspective, again, the founder, Scott Hassan, having had been involved with the early stages of Google with Larry Page and Sergey Brin at Stanford, as well as kind of like founding his own company, e-groups that merged into Yahoo and became Yahoo Groups later, had the opportunity to sort of like, enhance his wealth and wanted to sort of like get back into creating something truly revolutionary. And I guess in the sort of like mantra of Bill Gates, where if personal computers were so amazing for all of us as a society, what can a personal robot do? And started Willow Garage with a number of projects initially. There was an autonomous car, autonomous boat, and what we call the PR2, personal robot. But alongside kind of like building all these hardware initiatives, there was an appetite for building the software, and more importantly, the community that kind of comes with it. So those that, again, have been involved with ROS and the PR2 and have been directly or indirectly members of the community that Willow Garage kind of like created, might know, again, about the first iteration of this machine called the PR1, which was designed by Eric and Keenan at Stanford University, which became almost like the prototype, the blueprint for a much more complex robot called the PR2, which Willow Garage as a lab, I guess, kind of like, slash company really tried to kind of put it together. So you got, on one hand, a founder that has an appetite for technology and like very exciting futuristic things. He brought, of course, and put together a very impressive board of directors, advisory board, if you may say so, including people like Larry Page, Maya Matarik, Sebastian Thrun, Michael Black, who require like no introduction, and then really kind of like went out there to try to get as many people as he could in this sort of like complex of, let's get around 60-something full-time employees and about 30-something contractors, and really kind of like get together with a lot of smart PhD students all around the world, bring them over as visiting researchers, as interns, in an attempt to foster a community. Moreover, building this program that, again, was led by Eric and Keenan, that had kind of like the PR2 robot undergoing certain milestones. And if you look back in history, there were 4 defined. The fourth, which was, build 10 of these and, put them out there in the world, give them out to, academic universities, academic research institutes that can kind of like take it, become part of the community, and really continue building upon that. And so it's interesting because I think Michael will have a slide during his presentation that speaks about, the most successful failure, which is the fact that like the complete vision, as was initially presented, was not, obviously, did not come to fruition, was unsuccessful. Rosie from the Jetsons and all the dreams that we had, having an off-the-shelf robot that was, they were not realized in that sense. And what ended up happening, again, for those of you that don't know, after years of work where we put together 3 major software initiatives that became open source, like ROS, the Robot Operating System, PCL, the point cloud library, which was actually built from scratch and became kind of like part of the team that I was leading, as well as like OpenCV, which was a much older project, very sort of like popular, initially built by Gary Bradsky, my office mate at Intel. Kind of like we took that again under our umbrella and really kind of rebuilt a lot of things from scratch with a lot of help. Putting this out there, building the community, and then again trying to get a sense of how do we kind of get people around the world to sort of like share and contribute code and modules and into this like larger ecosystem, and really kind of coming together and trying to, again, take the dream to fruition, creating potentially a $1 trillion industry from a business sense in personal robotics, but really kind of advancing the state of the art. So I think even though, you know, Willow Garage ceased to exist and actually almost split in a way into a variety of spin-offs, some more successful than others, the thing that really they represented was this idea that, like, with, you know, the right sort of like mantra, right funding, of course, right founders, and the right focus, I think you can kind of like pull something together in a reasonably decent amount of time. I think it took about like 5 years to sort of like build this first iteration of the software and the hardware, and put the basis of this community together. What I think the hope was initially for the founders and people that work there is that this is going to continue and just kind of like enhance. So this is going to plant, basically, is going to plant a seed that's going to continue to enhance over time in the academic community, with universities kind of like taking the torch and just growing and becoming more successful. And to some extent, this type of like, you know, interaction that exists there in different communities in, you know, in academia should be way more comprehensive, right? We did it for open source software in a way with ROS and the other efforts, but there's so much more that requires to be done in order to kind of like bring this to fruition. So yeah, I was part of that journey as many others. We had a phenomenal ride, and as I said, even though the, you know, original goal wasn't reached, we ended up creating wonderful kind of companies out of the same mantra. In fact, I was as a sort of like engineer turned into a researcher, kind of like pushed and turned into an entrepreneur, becoming the CEO and co-founder of Fusion in 2014. And really, if you think about the team that we created at Fusion, we kind of put together, you know, some of the original members of the Willow Garage team as well. You know, Steve, Stefan, and Pantelis that, you know, ended up in various forms being part of that community. And then we ended up like taking some of those lessons, seeing exactly like how fast and how effective the focus and the energy that the team had there, how could that benefit us? So we've been actually working on the 3D, again, computer vision problems, trying to solve them from a different sort of like through a different lens in a different almost industry altogether. And as of the end of 2020, we successfully merged into a much larger corporation. So had a very successful exit for our startup, kind of like paving the way for the next generation projects that like we're going to be ending up doing, and also ending up sharing some of those learnings and going back into the communities that we initially were part of, you know, through OpenCV, through PCL, and others, and accelerating in some sense some of the computer vision modules that like we all ended up working with.
Cool. So that was Willow Garage and ROS and how that developed. And I think now it's Daniel's turn to actually say a little bit about what we are planning in Eurocore and I guess how we can have a bit of that success, right, in Eurocore, and hopefully have a bit of the community that actually drove us in those years, right? And I think we are trying to do that, right? And so Daniel will say a little bit about how.
Thank you very much. So actually, I'll just start with the first slide that you have already seen yesterday, because if you think about ROS and you want to compare it to our system here, the Eurocore, then there is some differences, but there should also be some similarities. So looking at ROS, what is really remarkable is that Willow Garage and others created an infrastructure, an ecosystem, let's say, that allows you to install any kind of software module that you need for robotics in basically no time. You can include navigation system, manipulation systems, controllers, and reasoning systems like we have seen today, yesterday. And the entrance hurdle is really, really low. And this is, I think, something that we need to achieve if we want to also interact like that on a higher level of abstraction. And the higher level of abstraction being that with Eurocore, it's not about exchanging software. We can do that with ROS. We don't need another ROS, right? It's more about exchanging information that you have created with your system, with your research, with your facilities, and use them and share them with others, and they can benefit from them without sacrificing the stack that they built over the last 10 years when ROS came up. Because even though ROS was spread wide, still the systems are, all of them are unique, right? It's not as easy as using an output of our manipulation framework of Justin and porting it to a PR2 or porting it to any other robot. So it's just not that simple. So you could start over in any lab and say, okay, we now do that, we use a standard, but if you say standard in any room with a roboticist, you will be there alone in like 1 minute. So what is it about? So the Eurocore should be the central starting point, let's say, for everybody to bring in information. What could be in it? So there could be the maps that we have seen. So this is the lab that we have seen downstairs. So this could be in, and you can see already that there's all like 3 completely different robots inside there, and they have completely different software. Like maybe the first 2 not, but on the back there's a proprietary robot. It's a Pepper system. And if you now want to have the Pepper system using the information for navigating in this environment that was generated maybe from this PR2 or from that industrial robot there, how would you do that? So you need to kind of somehow include a map there. There would be information about what was a good idea to place the robot. So which robot was able to go at a certain point and was successful in executing a certain task. So you see this here for one robot and for different actions. And this is actually something that I took from some slides of Michael. And the question is, how can we use such information for another robot that is completely different? Like it has a completely different embodiment, but still there's an idea behind it. A manipulator needs to go somewhere where it is able to do the task that it should do, like picking, placing, perceiving something as good as possible. And how can you exchange that between robots that are completely different? So you need a higher level of abstraction. Another example, again, taken from some slides of Michael here. In different environments with different robots, you have so many different tasks and you want to exchange information from that. So how does a robot, or how can you use, let's say, 3 different robots to assemble something? How can they know what the sequence of the assembly is? How can they know where the pitfalls are? How can they share where, again, to stand, to drive to? What is the best idea to do that? And then, also, it's about failure. So think about these 3 here. So again, completely different. You can see also they produce different signals. So if you just want to combine different signals of different robots for executing the same task, like grasping an object, how can you bring them together such that another robot can use this information to avoid exactly, for example, a wrong grasp? Maybe you don't want to grasp the small bottle on the very top because it's just not a good idea to do that. It's much more stable if you grasp it from the side. And if you think about that high level of abstraction, this is what we want to achieve with Eurocore. All right. So this is kind of a picture that we had for the proposal. And we don't want to start from scratch, also not here. So there is already modules out there. There were some efforts already out there, and we want to integrate them in what we think could be the next, like the next platform for sharing information between robots. So let's start actually on the very right. OpenEase is well known. It's basically developed here in Bremen, and it can be a starting point, and it's also what is provided in EU Robin by the research field of No, like led by Michael and also Alessandro Saffiotti. And it includes things like episodic memories, skill models, and map data. So this is already, we know how that works. We know how that works for a single robot, for similar robots. Still, it's a difficulty how to include here other robots. there is approaches that we will look into. Scene graphs are a starting point, but then you also need a common language. We were referring to that as the Esperanto of robotics. So how can we create this language that every robot understands, again, even though they are completely different? And so therefore, you kind of need to have a shared ontology. And with this shared ontology, even though your system talks in a different language when it's inside itself, when it's actually performing one action, it should be able to translate this into something that any other robot can understand. And again, there's available systems that would be a good starting point for hosting all of this. So there's the AI for EU project, which has already created a catalog of software. Again, just like we know from VeloGarage, software is a starting point, but we don't need to go a step further. And we could integrate this Eurocore inside there. And then also external repositories can be added, like your own repository. There can be access for humans, agents, and robots, and eventually we will not only be able to share information between robots, but even between humans that control the system, that engineer the systems, and so on and so forth. All right, what would be the results? I have 3 of them. The first one would be that robots understand each other to benefit on all aspects. And again, I would like to stress it that navigation is the simplest one. You can maybe convert your map into an octree, and then if everybody can understand an octree, you can parse it and read it, and then you import it again and convert it to your own map, and then you're fine. But it's about the details that come afterwards. What about manipulation? What about failure? What about also object detection may be more easy. But if you start with different sensors, like if you have a, let's say, laser scanner only, and you get information from a camera, how do you map that? So these are the questions, right? And then, that's super important, like robotics researchers also need to understand each other on all aspects. It's like, yeah, I can read your paper, I can even listen to a talk of yours, and then I will understand basically just a glimpse of what actually boils down to your system. I mean, I've been working with Michael like for almost 10 years now, but I still don't know all the facets of CRAM. And the question is, do we need that? To some extent, yes, but it should also be much easier for us to understand what the needs are of these people, what they require. And if we know what they require, we can share without knowing all the details, right? And then we can have people, we can include people. And actually, the interesting thing is then if we maybe do not know all the details, but some details, and we can speak on a higher level of abstraction, we can bring the people from A to B, we can bring them into one lab, they can work there for some time, they don't need to know all the information, they bring their formats with them, they work through the Eurocore, they go back, they have some more information, and then they can just, without transporting this infrastructure again back to their robot, include it, and basically they can go forth and back, right? So that would be the dream, like have them all the way over the place, and then other labs can be integrated. So this is what we are thinking about with the concept of this shared funding, cascaded funding. And I think that would be wonderful for an experience for a student and an experience for all the roboticists in a room if we could have an interaction on such a level. All right, thank you very much.
Thanks a lot. So now it's my pleasure to introduce Luisa. So Luisa will give a different perspective. So it's actually kind of going from research, from producers to actually end users, right? And I think she does an incredible job in the Knowledge for Retail project to get the different communities together and get something successful going, right?
Yeah, thank you very much, Michael, for the introduction. Yeah, I'm Luisa. I'm also working for Team Neustar. Daniel also already introduced us pretty well, so I'm going to skip this part. Yeah, Knowledge for Retail. We are actually the project coordinators, and yeah, it's a project which started in 2020, and yeah, it's going to end this year. So at the moment, it's really exciting because we're thinking about different business models and stuff. And yeah, actually, it's funded by the Federal Ministry of Economics and Climate Change. And yeah, for me, when I first joined the project, it was actually quite a bit of a surprise, because I thought retailers already know, for example, where which article is in a store, where which shelf is, where the customers are going, which ways they take and stuff. But turns out wasn't the case. So that's where we, with Knowledge for Retail, are coming in and trying to solve this kind of black box problem, because in my experience, it's also one of the results why the stationary retail is actually less attractive. I mean, I think all of us know that, for example, if you look for a certain product, it's much easier when you just, like type in a keyword in Google and get the product delivered to your door. And that's for the end consumers, but also for the people working in stores. I mean, we all know demographic change and stuff is going to come in the next couple of years. And we definitely have to see how we find a solution, because it's not that attractive anymore for people to do like repetitive tasks all over again. So yeah, that's where we with Knowledge for Retail are coming in. We are having the approach to build digital twins. So like easily explained, it's just like virtual representations of every physical object in a store, so every shelf, every product and stuff. So that's pretty much the idea, and the core of Knowledge for Retail is the Knowledge for Retail platform, which is going to go open source also by the end of the day, by the end of the year. Not by, that would be cool. One of the biggest part of the project is, of course, like as Micah already said, the building of the ecosystem. So there are a lot of different players coming together. On the one hand, there are like for example, companies which are providing us with sensors and stuff. So for example, Ubica, we heard this morning already, are providing us with the scanning data, but also Captura, we're getting the cut models from them. And that's actually the most interesting part, at least for me, to be honest, because all these different partners, like University of Bremen, of course, Technical University of Munich, Fortis, DFKI, and many others on the one side. On the other side, like industry partners, like we as Team Neustar, for example, but also like DM, Rewe, and so it's a really interesting and, for me, really inspiring ecosystem to just experience that. And I think it's, when I first joined the project as well, I was a bit like, I realized that there's still this misconception of like having this like crazy researchers doing their magic and no one understands this, and on the other side there are these like industry people, like really rational, just like crunching numbers, don't have feelings and just want to make money. And for me it was really great to like see that this hasn't to be the case, because for me, I mean, I graduated just last year, so for me, my time at university is not so long ago, and I was a bit scared, to be honest, to transition into the industry for that reason. But yeah, it turns out that, especially through project like, and I mean, Knowledge for Retail, I'm involved personally, so for me, this is a great example. But there are, of course, as we already heard, a lot of other examples for that as well. And yeah, I think also like reducing the barrier for companies to like try out innovative ideas and don't have to spend so much money, so much effort and time is also, for example, for our customer really interesting, because we have, when we, for example, have a problem with a customer of us, and then we can see or we think of a special solution, but there's nothing on the market yet. So we really value also the cooperation and the relationship with the University of Bremen, because we can just discuss ideas and just like spin around and try out new things. And I think that's actually something we should do even more, because I think for everyone it's really valuable. So that was a short intro from my side. Thank you very much.
Turn it on. Now it's working, right? So thank you very much. I think we can exchange really well here also with industry, because that's part of EU Robin and then also the Euro Core. Because innovation is really, really important for the project. Because maybe you remember the first sentence yesterday I told you, it's about how can we overcome the challenges to deploy robots in everyday lives, right? And language models are part of that. And so I think that's really, really well. Thank you very much.
Thank you.
Good. So then next would be Rudolf Triebel from also German Aerospace Center. I talked a lot about knowledge in EU Robin, but as you know, knowledge alone is powerful, but not everything. So there's also an aspect of learning. And if we talk about Rudolf, then learning is really a key of his talents also in robotics. And I think you need to integrate both worlds. So in the past, and also when we talk to people in EU Robin, it's always difficult to make a distinction between knowledge and learning. And some people say it's the same, and others say it's completely different. And maybe the truth is somewhere in between. But if you want to really have robots interacting there, then you need to approach that, and you need to do that with all kinds of different robots. And this is also what we will see from Rudolf. He's kind of an expert in. So I'm looking forward to the presentation. Thank you very much.
Thank you, Daniel, and thank you for the invitation. It's really a pleasure to be here. First of all, to clarify, I have the 2 appointments. So on my name tag, it says TU Munich. My main affiliation is actually at DLR, but I'm also guest professor in the currently at the at the Earth Observation Center in TU Munich. So yeah, if you just wonder why I have the TU Munich name tag here. So today I just want to show you a couple of slides of our recent work that we did in my department. Basically, I start with some just overview of the 3 main application domains that we work on. So we have planetary exploration robots, which we just recently had at Mount Etna. So Mount Etna looks pretty much like the moon, and it's not on purpose actually that we went there, because yeah, also from a scientific point of view, it's very interesting to send robots over there. And actually have a team of robots there that explore this environment, and they build a map together, completely autonomous, and they come together and bring some samples and all these kind of things. Then we have industrial robotics as a main domain here. And that's basically the one I'm talking today about here. And we have also, of course, service robotics. We've just recently shown on the Automatica trade fair this David robot loading the dishwasher here. Again, I'm focusing here only on the middle domain here. So what are we doing here? What kind of robots do we have here? We have mobile manipulation robots here. This is actually a video from last year's, already 4 years ago, Automatica, where we have different kind of systems here. This is the Sarah robot, and we have also a linear axis mounted LBR. And so the main questions that we try to address here in the domain of industrial robotics is how can we make sure that we manipulate objects in a certain robust way. And there's at least these kind of 3 major challenges that we have here. Of course, there are many others, but these are the main challenges that we kind of focus. And the first one is very often we might have very different objects, right? If we have lot size 1, that might be the case that we have every time that we manipulate an object, it needs to be something different, right? We don't know what these objects are. And this might be even unknown objects, right? We don't know the 3D geometry of the objects. We have to deal with that. For example, tools that we have never seen before, and we have to be able to manipulate them, to have to pick them and grasp them, and so on. Then, of course, we might not have enough training data, right? Training data is a very important topic here. And the last thing is time constraints, right? If we have a conveyor belt and we want to manipulate objects from the conveyor belt, then we don't have much time to actually decide where the object is and how to get there. And our aim is that we'd like to develop fast and robot object detection methods and also grasp prediction methods that do not require any hand-labeled training data. And we do that with kind of 3 approaches here. The first one is we generate our training data by ourselves. So we have this Blender proc here, which I'm just showing quickly here, which I really recommend everyone to view. It's open source. We can download it, and you can show how can generate your own training data with that. Then we use so-called class-agnostic learning algorithms, which I'm also quickly showing in one slide. And finally, we have a recent work where we can learn grasps from objects that are unknown. So we don't have a notion of the object, but we just simply have an efficient representation of these grasps, which we train in simulation as well. And with that, we can then get, with this two-finger gripper, quite stable grasps on random objects. So this is just a very quick overview of BlenderProc. This is the OpenGL counterpart, and this is how Blender looks like. So we can see that it's much, much nicer, of course, much more realistic, and that's what we want, right? We want to have pictures that look almost or as good as the real images. But of course, in addition to that, we can also have distance, right? So this is a different image, the same image, of course, but now with distance colored here. But we can also have segmentations and all kinds of other things. We have physics. That's the newest version of Blender. We just throw objects into the scene and can just generate new scenes from that, as you can imagine. And that brings us to the next idea to build a system that can learn from stereo input images to segment objects without actually knowing what these objects are, right? We don't have a label here, we just have foreground, background, and we train this purely in simulation. So we use BlenderProc here to actually train that. We have an auxiliary task, which is the depth, but we actually don't do this as a main task, right? So usually methods, what they do usually is first compute the depth, and then from the depth find the segmentation. And we found out that it's actually a better idea to directly do the correspondences between the images, and then from those correspondences find the depth of the images and segment them out. And that we can then use later to actually grasp objects, right? If we can segment them out, then the next step is, of course, to find a stable grasp. And here we have a recent work where we, again in simulation, train from 17.7 million different Sixtov grasps in this physics simulation here. It's a data set called Acronym from the University of Washington and NVIDIA. And so here we have an example how this looks like. So we kind of map the stable grasps onto the point clouds and then have a two-class classification problem where we say suitable contact points are blue ones and unsuitable ones are red ones. The intuition behind that is that a stable grasp should start from a point that you see, and then the other point should be then able to simulate it here, and we can then classify these point clouds into the stable grasp contact points and the unstable contact points. And this is a learning problem that you can try to solve here with this kind of network here called Contact Grasp Net. And the result is like this one here. We have a point cloud. We have also our previously shown segmentation frameworks. We segment the objects, so we know where the objects are, and we can get stable grasps for each of these objects. So basically this is the result. In the video you see how we have different kind of objects here on the table. And you'll see here the two kind of images. One is this instant segmentation mask that we get, and here are the predicted grasps, right? So it's similar to what Markus Winzer showed yesterday, maybe just with deep learning today. So it's a bit maybe brings some advantages because we have, of course, trained everything in simulation, so we don't have to train on these objects at all, so no hand labeling. We can also do transparent objects, as you see here. Of course, the glass has to be taken by the hand. And then there's a failure case here at the end, but this is something, of course, that you could do better because you could detect that this was not in grasp. It tries again and finds it then, so that's also good. And this is the nicest thing. So this is a cluttered scene where we have just a pile of things, and it's kind of stunning that it takes a grasp that a human would not have taken at the first time. But taking these things one by one, it actually also makes the scene whole easier, because then the segmentation problem is also easier, as you see. And then you can have the whole scene cleaned in the end. So this is something we would like to contribute also, of course, to the project with, right? This is, of course, very important also for, now it's not showing, okay. So to summarize, we try to learn to segment objects from synthetic training data. We use stereo correspondence instead of just RGB and depth computation. We found that the direct stereo correspondences are better. And we have this efficient representation to learn 6 Sixtov grasps. And we have a combination of unknown object segmentation and grasp detection. And in the end, we can grasp metallic, transparent, and even stacked and unknown objects in reasonably short operation time. That's it. Thank you very much.
Right, thank you very much. I think we can just right away start into the panel. So Rudolf, take your microphone and have a seat. Lisa, please take your microphone as well. So I'm moderating the session, but I also would like to be part of this panel. So if you have any questions, raise them right away. I think it's also super important because Eurocore as itself is something that is very collaborative. So it's really important if you have seen something that you would like to have, if you have some idea that you would like to bring in, just go ahead. But I'll start with the first question for Luisa, and this is important. As I said, industry will be a big thing, and the question is, you said industry sees scientists like wizards. How can you make it that they still are able to communicate with each other and understand each other?
I think, in my opinion and my experience now, it's actually like what's really helpful is working on the same problem and working on the same solution, because then you always come to a point where you don't know how to solve a specific aspect of the problem, and then you ask I don't like to say like they're the academic people and the industry people, but yeah, just to make it easier, I'm going to say that. And so the academic people and the industry people have to speak with each other, and yeah, doing that and communicating over the same problem, I experience is actually really helpful in that case.
Right, that's really interesting, and I would not have expected that answer, because it really fits the project again as well. Because what I have not talked about too much is the idea of how we will bring the different scientists together, because actually in the 3 domains there is a competition, but the cooperative competition. That means the 3 domains that also Rudolf showed, service robotics, industrial robotics, and outdoor robotics, there will be tasks given to the challengers, and they need to solve them. And they will have all of these challenges have their different infrastructure, and they need to overcome the problems together without exchanging the infrastructure itself, but with only exchanging the data and the information. Learning is a big part in that. You will be the robots will be deployed in unknown situations, and we have seen unknown objects, Rudolf. The question is, how easy or how difficult is it to transfer the models that you have learned with one robot to another?
Yeah, that's a good question. I think there's 2 aspects. One is the pure vision aspect, and I think that is something that is probably easier to solve, but I think, as Marcus yesterday said already, this is not enough, right? So we cannot just work on benchmarks. If we were doing that, then it would be easy, but in robotics, we can't just do that, right? We cannot just like train on a certain data set and then run it on another one and then say it works, right? So for that reason, we have to evaluate always that at the systems, at the robotic systems, and that is much harder to do, right? So like if it's not just the vision approach, but also the planning, if you have to learn how to do in motion and stuff like that, then it's not so easy to transfer that. And I think that's maybe the major questions of the project. How can we solve that, right? I mean, should we all do this in simulation? Should we do reinforcement learning in simulation? Also, that doesn't solve the problem yet, because we're not then yet there to actually bring it to a real system yet. I mean, sometimes, but not in general, right? We cannot guarantee in general that we have this transition to the real system. So I'm not sure. I mean, I think what is important is what you said in your presentation is to have this kind of common language. As soon as you have that, as we know how to talk to each other, also in this kind of learning aspect, then I think it becomes easier and actually possible to exchange these kind of learning aspects and taking what one robot has learned to the other one, so that this other robot doesn't have to learn it again. So this is the idea, right? This would be the coolest thing to show that we have one robot doing a certain thing, and then it trains it on a maybe new data set, and then you switch to another system, and it can do that already. And it has shown it couldn't do that before, and then because the other robot has learned it, now this first robot can also do it. This would be, I think, a cool demo within the project.
All right, thank you very much. I think I would like to extend the panel actually to more people in the audience, because it's really interesting. So first of all, you mentioned Marcus. I'm pointing at you. Yeah, he sees me. He's hearing me. There you go. What is your take on that? Because you had a strong opinion about this yesterday.
This looks nice in these tools. My experience is it's just really hard if you get a new set of objects. So I would, you know, we can just later on, but you know, for example, we got a lot of metal objects, and they had very nice models, but they were all wrong. I mean, they were not accurate enough so that we would have, particularly for objects that are a bit similar, not even super similar, but just a bit similar, enough distinctive. And then you really go out and either you think with the models, or you do something with the relearning, or you have to do something like put the objects just there, scan them, and make our own models, which, since we have the setup, always used to be the easiest case, including some very interesting texture properties. So there were objects that you know, the models don't tell you anything about texture. But it could be that the object has, for example, metal and then some plastic parts, and the plastic parts are totally dominant in the visual appearance. But if you don't have that modeled, you know, you just fail from whatever experience beforehand. So the trick is always in the details, I would say, and there's always some engineering left. At least that's what we found. And to really go to something that works all by itself would be super cool. I didn't show that yesterday, but maybe some of you have been at the European Robotics Forums, where we had workshops and a bigger study with David Warren on what industry people would really want. And the result basically was always show the task to the robot like you would to an intern. So show the task by really doing it, verbal explanation, 1 time, 2 times maybe. Let the robot execute it as the intern would do it, correct maybe the intern, and that's it. But that implies many, many things that we can't really do yet. I mean, first, of course, certainly a perception, but it's also this link of verbal commands or verbal expressions to some specific parts on the objects, to a specific action that the robot needs to do, and similar stuff. And it implies that the robot knows what all these actions are. So it understands basically its own knowledge, if it can do that or if it needs more knowledge. And I think that would be a fantastic high-level challenge to really approach.
Thank you very much. I think I would give the word to Daniel, because this is exactly what this is about, right? It's about language models, it's about identifying what's missing, and it's identifying about how to integrate that. So, Daniel, maybe what is your take on that? Can we learn the Esperanto of robotics, maybe?
I don't know. It turned out that it is actually really hard to learn the things that are not expressed in language, right? So we tried to make the connection between the language and what is actually like happening in the world, right? But I think it is a big challenge, and I think we are only starting here. And the language it turned out that the language that people are using is so abstract and so vague, right? That it is extremely hard to bring it down to a level that a robot can actually execute a plan, right? So there is a lot missing in what people actually say and what they mean, right? And this is still an open challenge.
Okay, that's interesting. So yesterday, Kay, you are still here, right? You have presented about speaking to robots. Unfortunately, I think only very few people understood what you talked to the robot. But how abstract is it that you need to talk to the robot? How abstract would a robot need to talk to another robot, which you also showed, in order that they can understand each other?
The demo that I showed yesterday is very simple because robot only, how can I say, we can define that the actions or verbs that robot can understand because we program that. So the trick of that video is people who talking to the robot is people who develop, write the software. So he knows what the robot understands. So that is the biggest problem at this moment because because normal, how can I say, ordinary people do not know what robot can understand. And if if robot do not understand what you said, how robot or how human react to do that, to that situation. So I think this is a very big challenge. If robot and human cannot understand each other, and what would they do next? So in the case of the human communication, we have a way to communicate more to deepen or clear the statement or problems. But at this moment, I think current AI does not have such a features. So I think my case is very simple one. And I just show some demonstrations. And we just found there is a lot of problem or challenges within that videos. Hope this answers your question.
Yeah, it does. It's challenging, and that's why I need to do it together. Thank you very much. All right, I need a little help on the time. I don't know how far we have been in the program. Oh, we are already over, right? Fine. It's really interesting, sorry. But yeah, one more time. There will be calls for participating in EU Robin, and I would be happy if we get many, many applications. Thank you very much.
together. Maybe when you're sober, maybe when it's summer, but I don't think so. Thinking love like this is raw and right and only comes once, but I don't think so. I'm out of my mind. You're better off there, you know you are. It never feels right. Well, maybe when we're older, we'll get our shit
thinking that I could have done something, but now I'm left with an empty heart. No making amends, no waking up beside you and holding you till we forget it all. How could I know there was no second chances? Like dominoes, my life got really scattered. You couldn't keep the door shut, and now the frostbite's creeping in. 'Cause I've been stone cold since you left me here, so come home. Why won't you reappear? Things that I said came out totally wrong. Can't speak of the truth when it's tainted. I fell into a big black hole. It got me stone cold. You got me stone cold. You got me stone cold. You got me stone cold. Got me stone cold. No Wizard of Oz can undo what I've done. Completely out of luck this time. I'm stuck in reverse. I gotta get away now, but I can't seem to take the lead. Oh baby, how could I know there was no second chances? Like dominoes, my life got really scattered. Still, I find myself hoping that you'll find your way back to me. 'Cause I've been stone cold since you left me here, so come home. Why won't you reappear? Things that I said came out totally wrong. Can't speak of the truth when it's tainted. I fell into a big black hole. It got me stone cold. You got me stone cold. You got me stone cold. You got me stone cold.
tide. Feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. Can make me move. You can make me move. Can make me. Can
if the moderator comes in, I will take over. Cool. So I think we had a number of very cool panels today, and with the startups, and also with the kind of introduction of the EU Robin network. And so these are kind of two facets of the game of turning robotics research into impact. I think the third is how robotics and AI-based techniques interact with established companies, right? And how we create synergies and how that works. So yeah, and we have some very good friends and industrial leaders in the team who do very exciting things, and we would like to hear from their perspectives about kind of what they are doing, right? And also from their perspective of how we can actually create more impact, how can we make the field more successful. And the first one is Heinz, Heinz Kirchhoff from Neustar. And Neustar, we already heard from Luisa, is the biggest software company around here, and a very good partner for us. And we like to be together in an ecosystem and do things together, right? So thanks for being here.
Thanks a lot for the invitation, and hello to everyone. Yeah, thanks for the grateful words. Biggest software company. Actually, we don't only do software, we do IT services along the whole value chain of digital development. So we start with requirement engineering, UX, UI. We do software development. We also do hosting and cloud services. So all along that strain, we offer our services. We are about 1,300 employees. About 850 of them are based in Bremen. For today, I brought two stories. One is from my life prior to Team Neustar, where I was co-founder of a startup back in 2007. And what we did, we were inspired by the RoboCup. I think most of you are familiar with this, which is purely a scientific event, but we thought it's a good technology and it's a good AI application that we can commercialize. So we founded a company in 2007. We were inspired by the Simulation League, which is the league which does not use physical robots. So all the players that you use in the simulation are software agents, autonomous software agents. And what we did, we signed a contract with the German league, with the Bundesliga, which allowed us to use not only the names, but also the performance parameters of the real players, which means in our game, so we made it a game product, there was a software, Schweinsteiger, you know Schweinsteiger, famous player in the German league, and we took his parameters like acceleration, goal strength, pass accuracy, and everything like this. We put those parameters in the software Schweinsteiger, and in the simulation, he was performing like in reality. And it worked very well, except one learning. So as you can imagine, it was very sophisticated, and we were very proud of what we had developed. And then first line in all the marketing and promotion stuff was AI-supported simulation. Well, the gamers had a different view on this. When they won, it was perfect. It was the best AI thing they had ever experienced. But when they lost, it was, of course, the worst AI they had ever seen, and everything was fake and everything. So that was a learning we took from this, but still commercial-wise, it was very successful. It was a game, and later on, we made it a virtual sports betting application, which then really scaled globally and which was very successful. So inspired by Bremen AI technology, we made this a quite nice success story. And the second story is what we do in Team Neustar. You heard some of our activities, knowledge for retail. We have more. We do AI really from the business perspective. We don't have R&D, to be honest. So it's always using AI technology that comes from science, preferably from Bremen activities, and then we commercialize in different industries like tourism, logistics, insurance, environmental technologies. All there we have AI components. To be honest, it starts with data projects, and then at some point AI components come into the game and make it successful. But from the commercial view, maybe 90% is data and 10% of the business success is the AI component. But it only works when it comes together, which is important for us. So the topic of this panel, I think, is a little bit how do we, from an industry perspective, deal with science? And for us, the challenge is to find the right timing, the right moment when a scientific development is the right thing for us in the business. And this is always a challenge. There's no one fixed point where we say, after 2 years of, let's say, scientific approach, and now we take it and then it becomes a success. So in every technology, in every project challenge, you need to find out what is the right technology, and that's a challenge. It requires an ecosystem. It requires a very close communication with all the partners, and we feel it works well, but it's a permanent challenge. It's not like at some point it works on its own. So that's our view on this. Happy to be here and to discuss further on this topic. Thanks.
Next, oh, I take this one. So the next panelist is Georg von Wichert. Here. Yeah, so Georg is a very, very long friend, and I think if we are looking into big companies, I think he is the one who was constantly looking into AI and robotics throughout the years, long before it became fashionable, right? And he was also looking in Siemens at pushing that. And we know each other from TUM, and where we both were in Munich. And Georg was also Rudolf Diesel Fellow at TUM. So he always kind of kept the bridge between academics, but also then industrial innovation, and very reliable partner for the European robotics community and Germany. So.
Okay, thank you.
Oh, yes.
Yeah, so, yeah, thanks, Michael, for having me here. Actually, I like very much someone said before that you have to, if you need new talent, you have to grow it yourself. And actually, besides doing all of this, I'm still doing lectures at TUM, and there I get the students for the first time, right? And then I try to pull them out of TUM into Siemens, yeah? So it's a very good approach, I guess. So in general, Michael asked me to say, as you heard, something about a transfer between academia and industry. And just a second ago, he also said, yeah, we want to know what these guys are doing. So I added some slides on that shortly. Yeah, obviously, I work for Siemens. I think for most of the Germans here, I don't need to introduce Siemens, but obviously we have a very broad industrial business. And so reaching from automation in industry into healthcare, trains, power plants, power distribution networks, and so on. And of course, this means, as our propaganda slides say, that innovation is the basis of our success. And it's clear that with this broad field and the quick developments that we see in technology recently, this is nothing someone can do just alone, right? And so thinking in ecosystems, innovation, and open innovation, and so these are really important topics. To introduce me and my group a little, so we are part of this 4.9 billion R&D, but of course This is also the normal product development. So if we look at this distribution here, we can see that the Siemens technology, which is something like the Siemens research where I'm coming from, we are just a part of this with roughly 2,000 people working, most of them being researchers and also doing all the IP for Siemens. So we're just 2,000 out of these 42,000 R&D employees. And I think we get, it's not on the slide, roughly 500 million is what we consume every year. When it comes to innovation, I picked one or another propaganda slide, is what Siemens currently always says is that we are bringing together the real and the digital world. Yeah, also all these ideas of the digital twin and to use it for automation, and so that's obviously something Michael is doing, and for us is also really important. Why is this interesting? Because what our long-term vision is sort of to say, to have all the digital data about the products, the production, machinery, and so on, and out of this generate in industry, in our industry department, generate automation automatically. So I have a small example here. I think I can. This is, the example is a production line. It's synthetic, as you will see, a production line for back panels of electrical cabinets. Yeah, you have cable ducts and DIN rails onto which you later clamp our cool automation components, and to design. And these things are basically more or less lot size 1 manufacturing. Yeah, so this is a prototypical tool where you can design your cabinet backplane, yeah, by just putting some cable ducts in this case, and DIN rail here, it's an H for whatever reason. And then the idea is we have this digital description of the product, and out of this we automatically generate the production plan and all the motions of the robots and the AGVs and so on. It's actually a planning system that does this here. That's real. In reality, it's much faster. The visualization is slow in this case. But maybe I can fast forward it a little. So it tries out to find a solution and then details this. So it's some kind of a hierarchical planning system. And what we at the end get, and this would be the kind of goal, is to have a factory which produces stuff. Already here you can see some blue parts. Our new product that we just designed will consist of green parts to show it in the simulation here. And so what we do is we basically compute all the activity of this on demand, including the motions of the robots, the AGV's decision which station does what. Yeah, so here we have some cutting machines and a forklift that picks parts from the storage, and I fast forward this, and until finally one of the AGVs brings these green parts to this station, which will now manufacture the cabinet that we just designed. And the background factory is also producing other stuff. Yeah, so this is this kind of idea to have to maximally exploit the digital data that we have to replace a lot of, in this case, engineering work. Yeah, so and obviously this is a big topic, and this is still the beginning, and so on. It will take 4 years, and we know and understand that we cannot do this on our own. So we as a company very heavily rely on external collaborations, also with universities, in very different formats. Yeah, so we do bilateral projects. We do together with universities funded projects. We have a postdoc program and industrial PhD program. We also collaborated in various dimensions together with Michael in the past. Yeah. We're doing lectures, as I said. We are doing research. At the end of next year, we will co-locate our whole R&D or research department with TUM. So we will move with almost 800 people onto the campus of TUM end of next year. Of course, we support all kinds of activities with sponsoring, and we like to exchange experts, obviously. Yeah? So we have this complete chain. But if we then think, okay, do we want to do in these collaborations? Obviously, you always have some kind of a chain. Yeah? You're doing research first. Yeah? Then somehow this generates ideas, and they then will need to be validated. Yeah? Those writing EU proposals will notice that these are actually the TRL levels mentioned here on the slide. But it's actually what we do, right? We do research ourselves and collaborate a lot with universities and try to pull in stuff from outside. Then we somehow need, out of the research project, for example, this year is a system that does assembly, very flexible, just out of a product description. It's a lab demonstrator. Then we try this out in our factories, for example. Yeah, that's a bin picking system, until we finally end up in some kind of a product development. Yeah, and one example which I want to use to discuss about or to talk about the complexity or what actually the task is robotic motion planning. And it's needed in been done research on a lot. I talked to Darko before. Rarely used in industry at all. Yeah, almost none. I think this is actually the largest application in terms of numbers of robot motion planning, because for more than 10 years we built these motion planners into these medical devices. But the question here, of course, is to make it a successful product out of the motion planning as a technology. It takes, of course, a lot of development, but also to understand what actually the need of the people, of the customers is, right? And here for this, we highly rely on collaboration with academia to find the good ideas. And finally try to bring them into products. Yeah, and actually I have on my last slide, I have a quote by Giulio Sandini on LinkedIn last year. I don't know, actually I couldn't find out anymore why he said that, but I like it a lot, yeah, because he said there was obviously discussion on research and research questions, and especially if you go to US, the university is very academic, and say we're not interested in applications, but I think, and here he says this doesn't really make sense. We have to understand that we need science-driven research to get good ideas, and then do engineering-driven research, and this is where I think universities, especially in Europe, collaborate very well with academia to bridge this gap from just a good idea, the motion planner, to a useful one, and which might be the product. And for motion planning, for example, I think we're not yet there, surprisingly. Yeah, and so that's my point. We can't do it alone. We want and actively collaborate with academia, and the task of us always to find useful ideas. Thanks.
So thanks a lot for that presentation. The next panelist is Moritz Stenot, and Moritz also got his PhD from our group, right? And yeah, Moritz went to Magazzino, is Chief Technical Officer at Magazzino, and I think he's taking a tremendous challenge, right? So I think kind of having autonomous mobile robots that kind of manipulate objects in the world with some generality is the most complex things you can imagine, right? And it's just you have to look at autonomous driving, right? Autonomous driving is only going from a start point to a goal, and without having collisions, right? But actually manipulation is changing the way, the world the way you want it to change. And I think it's in robotics kind of the ultimate goal, right? And I think it's tremendous to have kind of a German company that takes on the challenge and is so successful with it. And yeah, looking forward what you have to say to us.
Thanks a lot. So as Michael said, we are looking at mobile manipulation, mobile pick and place. today I was asked whether we actually do manipulation. We are doing it, but we're doing many things in a very different way than you might have seen. So we are not picking glasses, we're not picking from heaps of stuff, we are not picking bananas or any other things. So if you look at it, we are taking boxes from stacks of boxes. And when I started into this, I thought, okay, how boring can something be? So what is the most boring thing to actually pick? And we're doing that using a gripper that is also not like a 6-degree freedom arm, but it consists of mostly linear axis and some rotational axis. So it's something very simple also from a kinematic point of view. And you think normally if you have a linear actuator that you also exert linear movements onto the objects. And if you look at videos and you do this often enough, so if you have millions of pics, then you see that you can exert any kind of 6-degree freedom motion onto objects. You can flip them, you can pick the other objects and so on. So can show some of you later. It's really interesting what you can do with a purely linear axis and with a purely, most of it, cuboid item. So what we're doing is building robots. So here you see some of the robots that are working at Zalando. This product is picking shoeboxes because shoeboxes are kind of the simplest thing that you could use. They are stored normally in steel shelves in stacks, and these devices are bringing them from the shelves to the outbound desk. So if you're ordering shoes at Zalando and they're coming from one of like the 3 distribution centers here close to Germany, it can be pretty likely that our shoes have delivered them. And if you send them back, which also people do normally for 40 to 50% of the time, it's also pretty likely that our robots bring them back into the environment. How they're doing this is by a gripper that is here inside a tower, so it can rotate. It has a linear axis, it has an array of suction cups, basically pulls the objects out. And as you're seeing here, the stacks are mixed, so it can also pick out of the middle or the bottom of a stack, which is something really important, but also pretty nasty to actually implement and to get to a level, as I said, that is useful for the customer. That is the biggest challenge. It's not about doing it once, it's about doing that 24/6 with large fleets without any one of you being on site and competing with a human in the business case. And that's, in combination, something that is a bit hard to do, and where we also thought if it's a good challenge to pick. So there might be easier ones and easier ones to actually become profitable and become sustainable as a company. It's a pretty big leap that you need to do. We started off in the shoe market. Actually, we started off with books. That was even worse. But shoes was the one where we have a larger market and also kind of a homogeneous market, but it's still not really large enough to sustain a company of our size. So we were looking for a second product, and currently we are building this up for industrial supply. So what you're seeing here is the largest sibling of the robot you just saw. It's a plant by MAN in Nuremberg, where they're building motors for trucks and buses. And basically all the components of that that you're seeing here are delivered in these kinds of plastic boxes. So there are smaller ones, larger ones, 60 by 40 by 40 centimeters, or half of that, or quarter of that, or something, up to 20 kilos heavy. And currently those are all transported by humans in there. And this part, the logistics, is almost not automated, while the assembly line is often highly automated. So what our robot does is to pick them up from what they call the supermarket, or like an automated storage system, then navigating through the environment, and basically delivering them to these flow racks here. So you push it in on this side, it's rolling down to the other side. Here's the worker who takes out the items and then assembles the motors based on this. And here you see how this actually works. So the robots have to navigate in an environment that is pretty populated. So there are forklift drivers, there are humans, there are other AGVs. Basically, the manufacturing line is not a conveyor belt anymore. There's also AGVs, like the one you're seeing there on the side. And they have to coordinate in this pretty tight spaces here. Have to pick up and put down items at different heights, and then check, for example, which are the empty ones. Have to be safe in collaboration with humans, have to live with disturbances that humans are creating, like obstacles on the way, shelves that have moved, and thereby they need quite a lot of perception of the environment and need to be able to react upon this. And also those robots are used by the people on site, so they're not used by robotics engineers, so they have to be easy to understand, easy to set up, easy to have errors solved. And this is also a big challenge. If you build a complex thing, making that simple is something that's even more complex on achieving this. And so here also the gripper is not what people usually call a gripper. It's basically some conveyor belts that are going underneath, but that gives us the flexibility to grasp all kinds of different types. They are standardized. Standardized doesn't mean that they're all the same in one company and doesn't mean they're all the same in other companies. So this is a standard that is mostly like the outer dimensions plus minus some centimeters, but in between it can be a cardboard box, it can be some styrofoam boxes, can be whatever. So you can't rely on much in this in order to grasp them. So today I was asked to talk about collaboration and transfer from academia to industry, and besides also some classical collaboration like EU research projects and so on. I think if I had to pick one example, it was basically what I learned from a university time and what I could transfer. And you saw many of the demos here. Back in my generation, I defended 11 years ago, so it's quite a long time. We planted maybe some of the seeds that now have been turned into something cool by all the others that followed up in the next generations. But I think what was special in our group is that we were already then building systems of robots. So we had a mobile manipulator that was driving, that was at a high-level executive, that could perceive the world, that could interact with the world, that could reason upon the world, whereas many other groups focus on individual algorithms and components. And if you want to build a system, it helps to learn how to build a system somehow. So it's something that is really taught and that many people don't really give a lot of credit to. But for such a robot, many components have to work together, and the architecture is something really important. So if you look at our software stack, we of course have many of the robotics functionalities like navigation, localization, perception, grasping, and so on. We also have some parts that are outside of the robot. And those are coordinated by our, we call it across core. It's our behavior tree that here in Bremen is the equivalent would be the QAM stack, the executive, that is doing the high-level task execution and basically telling the robot, the other components, what to do in which sequence. And it's taking these decisions based on what it sees at the moment and based on what it knows as background knowledge. And here these data models, in Bremen speak called NoRob, are also underneath and allow the robot to memorize, but also to reason upon this and derive new information. We even nowadays have some prologue in the system for doing some diagnostic reasoning, because often robots throw some random kind of errors and it's not so obvious for a robot what you should actually do in order to solve a problem. But by applying some generic rules to this, you can understand much better what happened, and you can also infer what to do now. So with our behavior tree, just one short slide about this. It's a somewhat different approach. It's not written in Lisp also, fortunately or unfortunately. But basically it serves the same role of having a high-level coordinating entity where the different other components can feed in the data. It's encoding what to do. We learned it's really important to support a very complex behavior. This is just a trivial example. The real tree is like 500 nodes that are working together. It has to be really reactive, so you shouldn't just wait until the cycle is over to react upon something, but often you have to react in the millisecond range. And in order to edit and maintain such a complex system, it's really good to be modular and reusable. And these 500 nodes often consist of templates that are instantiated in different places. And for a human to understand this, also the engineering support and, for example, here graphical tooling and so, something that we found to be highly relevant. And also is a part of our software that is now licensed by other companies who are also building robots and would like to use it and basically learn from the experiences that we made the hard way. Cool. Thank you so much.
Now we have a short video presentation from Dr. Albrecht Ricken from SAP. And unfortunately he got sick, got corona, and can't be here. Yeah, but we are looking forward to watching the video, and then we step into the discussion.
Hello, my name is Albrecht Ricken. I work for SAP, and I used to be the product manager for warehouse robotics. This is a solution that allows vendor-independent integration of autonomous mobile robots with our solutions, namely with extended warehouse management. In the past, we learned that automation pays off at scale, and this changed with the advent of autonomous mobile robots. They make automation not only affordable, but they also allow one-off tasks. Yet challenges remain when looking at such robots, at autonomous mobile robots, and these include expensive system and process integration. So integrating such robots with warehouse management systems or with ERP systems typically is a project that takes 3 to 6 months. Another is vendor lock-in. Once you have created this integration, you have a stack. Changing and using robots from a different vendor typically requires a whole new integration project. And finally, challenges around IT strategy and governance, namely because these stacks from different robot vendors need to be managed in terms of user administration and in terms of security patches. Created warehouse robotics out of a collaboration, by the way, with Google. What it is an integration of for autonomous mobile robots that work with such robots from any vendor. So regardless of the type, regardless of the make, as long as it is an autonomous mobile robot, you can do this integration. And it is an easy integration. So we are talking here of hours of integration, possibly a day initially, but not weeks or months. Another thing is that adding then new robots is something that is possible ad hoc, that is possible spontaneously while in operation. And the third is that it is possible to manage heterogeneous fleets in a single solution. Now the question is, how do we do this? What is the secret sauce? And the secret sauce is that we are looking at the robot very much as if it were a server. So we have a cloud solution that deploys onto the Kubernetes clusters that can be on the robot software and makes sure that the software is installed, is updated. And because of this Docker architecture, of this container architecture, that this allows to run independent from the specific hardware stack. So we have a cloud solution that controls the robots and then assigns specific tasks to the robot, such as move an item from A to B. So in fact, a whole warehouse order is transferred to the robot. And this is pretty much scenario A, transferring a whole order on the robot where the robot itself can confirm it, has the additional beauty that the system is highly tolerant towards Wi-Fi outages. So if the Wi-Fi signal is lost, the robot can continue executing its order. And once the Wi-Fi signal is back, it can resume and can update this, the system with its confirmation, for instance. In another scenario, some robot vendors do not have this control right on the robot, but have something like a fleet manager who controls the robots. In that case, we would deploy the software onto the fleet manager. And in a scenario C that we have here, this fleet manager is in the cloud. And again, there we would deploy then our solution. The beauty is that you have a 100% shared code line for different types of robots, as well as for different scenarios, A, B, or C. And to conclude this, what we created is an OEM agnostic architecture with a maximum of flexibility, a freedom of choice of the robots, multi-device and multi-use case fleets that can be run in a single solution, out of the box integration with SAP Extended Warehouse Management and a later stage with our manufacturing solutions, and an IT governance that automatically extends to robots. And with this, I appreciate the opportunity that I was given here, and thank for your attention.
Yeah, so I think one of the first questions, right? So if we have autonomous mobile robots, right, and they are so essential as an infrastructure for a country like Germany that has so many factories, shouldn't be kind of the software infrastructure for building the control systems for such not be something that should actually be government funded, and if we don't get the money for that, do we actually have to actually get the people together in some other form to build an infrastructure? It seems to be an infrastructure that is needed by everybody for everything, right?
Yeah, maybe I can take this. I'm not sure if government funding is the one that is missing or that would be most beneficial. I mean, of course, it's always nice to get money, but on the other hand, it helps to focus as a company on building something, and also to be exposed to real-world problems in order to solve the right problems that you're doing. So we initially set off and had the goal of building the software stack and making that also in a way that others can benefit from it. But we decided against just building a software stack because we believed that doing this in isolation wouldn't yield anything useful in the end. And also our beliefs about what you need changed quite a lot. And we discovered many things like, for example, what Albrecht just said, deploying updates to robots in the field, having IT governance is something that you wouldn't expect from somebody from more or less, at least in our hearts, a startup. But if you have a fleet of robots out there, you need to manage the software state and everything. And this is something that has been discovered by actually being out there, having products, being a live operation, and also sometimes having some resource constraints helps to focus. The resource constraints should just not be so severe that you basically have to, do hacks or are dying on the way. That's not useful, of course, to run out of money. What I think would be really useful is to have a broader support and maybe more cooperation between different companies working on this, and also shouldering much of the base infrastructure. So, for example, building code, automatically testing code, building CI pipelines, also things in ROS like having a 3D visualization. Those are things that you don't want to do yourself, but that you need in order to develop products. And having an ecosystem for those kinds of components and infrastructure patterns and also best practices in how you build this, I think could help many startups to develop their infrastructure on top of that. But at the moment, many have to invent this themselves and basically start from scratch again.
Yeah, that was my concern was a bit, isn't there the danger that kind of everybody is reinventing what the others already have, and they are kind of reinventing in a worse way, and it's kind of a huge waste, right? and one wants to avoid that here.
Only danger, I think it's what's happening at the moment. And normally when you build a product, then basically your development infrastructure is usually not what you invest in most. So some of the software companies do this and have some of their best engineers as basically for running their developers' experience or running their site infrastructure and making this reliable instead of focusing on the products. But in robotics, usually you focus on the robotics side, and the other part is seen as overhead, but actually it can have a huge lever in order to become more successful.
But that also implies that turns robotics into a huge software problem, right? And I think kind of you need to invest much more than you expected in that part. And I think if you look at the robotics community at universities, right, the structure of people look very different, right? So they are not software engineers and building systems. Is there anything that has to change to get the situation better?
Yeah, I think valuing systems engineering and thinking about how to construct a robot system on robotics side, but also how to build the software engineering workflow, for example, is something that would be beneficial if more people took care of this and also look at it from a research point of view. So, for example, we had a research project with the Fraunhofer Institute about using DevOps principles actually in robotics and adapting the challenges that you encounter when you want to do, for example, automated testing of a physical device or of a device that is autonomously taking decisions. It's not so easy to just have perfect test coverage compared to like a purely virtual environment. So if you're just resetting an environment, in one case you're spawning a new container and you have your original setup there. In the other case, you have to tidy up the boxes that the robot has dropped beforehand. And that means you need somebody who's actually taking care of the environment to be clean. Right. And so I think more research in this area would be really helpful, and also having more best practices that are being developed.
So I guess a question for Georg would be if you are kind of in such complex applications, right, and you want to work together with universities or academic partners, how much is the complexity of the software, and that kind of a university partner would typically develop only a component, right? And is that a problem, right?
Yes, of course, and I think this is not just in this constellation, but I think this is why ROS was such a success, because then system integration becomes way easier, right? And of course, if you it depends also on the kind of task. Yeah, I mean, if there is a lab that has a very elaborated system, and you need to set all this up and get it up and running and working in order to do something together, that's a challenge of its own, I guess. Yeah, so I think standards and I think over the lunch we talked about the navigation stack, for example, in ROS. Yeah, so currently we are working on something that we call a manipulation stack, with the same idea to have like an architecture pattern that you can plug individual modules in for different tasks, for example, or subtasks. Yeah, like you have the I don't know, cost map planner in the navigation stack in ROS. And I think these kind of architecture patterns will be very important. Unfortunately, my feeling is at the moment they didn't, except for this in navigation, they didn't yet really develop and emerge out of the work. Yeah? So I think this system integration is always difficult, right? And it's a science of its own, yeah, for sure, I guess.
And I mean, if Siemens develops such a manipulation stack, would Siemens be willing to share it with the community, or is it something that is so deep toward a kind of?
No, I think times are changing a lot, right? If you listen to the other propaganda slides that I left out, we are very much the strategy is to go for ecosystems, and Siemens aims to be a provider of like the basic infrastructure of this. So that everybody talks about APIs and so on, and but it's especially in automation, I think there is still a way to go. Yeah, the daily practice in industrial automation is to, how did you say that before? Individually knit together a system for a specific customer. Yeah, and there's not really a software development kind of ideas behind how this is done today, and this has to change. But I'm sure it's going to change, and we also seem to be going in a direction where we offer our own software as modular services that we can either use ourselves or our customers use them or the customers of our customer. And so this will be very open. I think it's going in the direction, but there's a lot of work on architectures to do, I guess.
Right. And so just speculating, so as we are thinking about Eurocore and EU Robin, would that be something that you could imagine Siemens being interested in and also seeing as a vehicle, or is it just kind of?
I think it's difficult to say at the moment, yeah, because this new way of thinking about selling even half products instead of just completed boxes that you can push over the counter will change dramatically the business as well. Mm-hmm. And this will also have an impact, I guess, on the kind of what we as a company see as part of our portfolio. Mm-hmm. Yeah. For example, at the moment we are very much a provider of equipment for other people automating other people's processes. So we basically sell towards system integrators, and system integrators build machines or plants or whatever out of this for the end customers. And as such, we're very much doing modules only. We're not doing applications. Yeah, for example, if you think in welding, for example, welding robot, there was Reis Robotics, now bought by KUKA some years ago. But there's specific experts for these kind of applications. The more software is in the products, the more you might have application modules, yeah, which at the moment is not yet the case, right? So it can change a lot. And so I think it's still difficult to say how this will go. But as I said, yeah, our management also talks a lot about ecosystems, yeah, and Eurocore, and so also it's same kind of idea as far as I get it.
So thanks, so Heinz, from your perspective, right? So we could also see robots as a window in the real world, right, and as a natural extension of intelligent systems, of database systems. But on the other hand, I think going into robotics has that enormous complexity, right? So I mean, in terms of software development, also how long it takes. So for a company like Neustar, who is actually exploring in all directions, is that something that would that Neustar wouldn't do, because it says it's kind of too long investment, it's too big investment, and we rather wait and see what's happening? Or is it something that Neustar could also be interested and say we want to be a pioneer in, right?
Yeah, good question. So wait and see doesn't usually help the business, so this is not what we are doing. I'm pretty jealous on my colleague who has an R&D unit of a couple of thousand people, I understood, and 500 million of budget. As I said, we don't have it. We don't do R&D on our own. We are always driven by the customer. So if the customer approaches us with a project, then we are of course forced to provide latest technology, which includes robotics, which for us is mainly software robotics. So we don't do any physical robotic stuff, although we just start to build a relationship with KUKA. But again, we will only be on the software side. But it's very interesting. So we are usually customer driven. So there's a project, and the customer comes with a challenge, with a requirement, and then we look into the right technology and how do we get it, if it's AI or if it's robotic. Right now, we look into university partners like Bremen, and we look into talent. So the transfer, which is the question here, is for us, it's a transfer of talent. So the guys in the room who moved from academics to us in the company, there's someone in the room who we share. So it's 50% in the university and 50% in our company. And I saw one of software projects here in the demo, which is also becoming right now a part of a product we sell to customers, which is called Daniel is the guy, and it's called the Recommender. So it's still a science project, but it's also used by us in a customer project at the same time, and that's what makes it for us. So that's how we work and how we depend on, but also support scientific work.
Cool. So any questions from, oh, cool, Rudolf, please.
Yeah, I have a question regarding common funding between industry and academia. It seems to be there's many calls where you actually require industrial partners as an academia partner, which puts a lot of pressure on the academic partners because we have to find industry partners very often. But this pressure seems to be asymmetric a bit because industry partners don't have this pressure somehow. I don't know, I mean, maybe you have other opinions on that. And the question is, what's the problem there? And how can we solve that? Because very often we face this problem, we have a nice idea, we find an industry partner maybe, and then they jump off or whatever, right? We just had this in European as well, right? One partner jumped off just before the deadline, and this is, for us, very often a problem because we need that money, right? We require that money, and maybe industry doesn't do it that much. And so what are we doing wrong? I'm not sure. I mean, maybe you have an idea on that.
Me? Okay. Yeah, thank you. Well, to be honest, I said we are the research department. So we have the same problem with our business units. They tend to jump off. Sometimes after the project was granted, academic partners completely crazy and disappointed. And I also had a case where the colleagues wrote to the funding agency that the reason is they're no more interested in the application of this technology, which was just not true because it was just a reorganization. Yeah, so we had to. Yeah, so I know this problem, and obviously, I mean, for industrial partners, sometimes it's easy to take advantage of the situation. Yeah, so we did this in the past, I have to confess. Someone calls with an almost ready-made proposal, and we just join. Yeah. So actually, I stopped this in May, where I'm. Now we very much try to define the projects together with the academic partners. Obviously, we have limited resources because I've not the full 500 million. No. So in the end, we have to select, and of course, this always. That's something that for me was very difficult when I joined industry to understand the different kind of motivation. In research, you say, yeah, that's an interesting problem. I want to work on it. And they go to DFG and they give you some money, which is great. Of course, for us, it always has to be promising in terms of business. Then it has to fit to our basically the business mandates of the individual business lines. For example, also a hard thing I learned, we do a lot in healthcare, but we don't work for care. We work for the doctors. Yeah, so Siemens has almost no entry into the care domain, no market entry. Yeah, so we cannot do that because, and there's so many things that make a good proposal and a good idea not interesting. Yeah, I think you're not doing anything wrong, to be honest. Yeah, I think, and of course, I mean, while the Commission always says that at least in the H 2020 had to be industry-led, right? I would be careful with this, yeah, because we need the leadership in the academic side to come up with the good ideas, right? So I'm not so much a friend of industry dictating what's a good research topic, I have to say.
Yeah, I mean, we are a small company. We don't have a research department, so we basically have to do that with our development team. And I'm always afraid of defocusing the team. I mean, also internally, we have many good ideas that we are not following, and we always have to, keep ourselves to actually delivering on what we need most for making revenue, and this is getting these products ready, usable for the customers, well integrated, reliable enough, and so on. And then another factor in a startup is that the world is changing pretty quickly, but the timelines for projects are super long. So normally it takes about a year before you get the notification or before you can even start a project, often longer if you have to submit it twice. And then it takes another 3 years or so until it's finished. And so throughout the whole time, you need to make sure that the topic is still relevant for you, because if it's not relevant for you, people won't care, and then you can also not deliver, and maybe it will drop out later. But at the same time, it shouldn't be too relevant for you, because then you need it more urgently, put your own resources on it and build something. And so you can't wait for the results, basically. And finding the balance between this is something that is pretty tricky. And I personally also rather reject beforehand if I can't give the commitment that I'll do something in this project, instead of going in something half-heartedly and then, not really being involved. So we've been involved in pretty few projects. Maybe we should have done more in the past and take more money and just participate. And maybe the academic partners wouldn't even be sad about this if we just did nothing, because they could also get the money by this, but it doesn't feel right. So it's not the way it should be. It should be about collaboration and actually both sides contributing something. And if we can't really commit to contributing, then we'd rather not do it.
Yeah, oh yeah. So,
This work? Yep, it does. Well, fully with you, it can be very disappointing to search for partners, and then you have those who just participate for an opportunity and are not really interested. And for us, this is now why we are very happy in Bremen. We don't discuss projects where one of the partners knows it's not relevant for the other. So this is a situation that develops from a very close relationship, which we luckily have in Bremen, I'm happy to say. Of course, we get approached from many other institutions where we very early decide not to participate. And then you need to be honest, and to avoid frustration, just be honest and say, no, it's not the right thing for us, and we will not bend in some way to participate, knowing that it's not the right thing for us. So this, I think, it's a matter of honesty and trust, and this requires a little bit of maybe a long-term relationship or mid-term relationship. So you need to know your partners, and then you can avoid it.
Cool. So thanks a lot for the great panel discussion, and I give the microphone to Rudolf, who will lead the next panel.
Yeah, we just go right away without a break. It's my pleasure to jump in also to moderate now this last panel discussion. I would like to ask the speakers to present themselves. I think if it's kind of the order that is written here, I was asked to do this this way. So I think the first one will be a video, and it will be Amit Kumar Pandey from Being AI. And I think we can play the video.
Hello, everyone. I hope you all are enjoying this event. My sincere apology is that because of some strange regions out of our hand, I am not able to participate in person in this very interesting event, which I was willing to participate and interact with you all and meet you all after so long time. So let us hope we will have another opportunity for that. So today I will simply highlight some of the opportunities from the industrial perspective, where exposing some of the needs and see how we can collaborate together in robotics, avatar, or AI domain. So the first question is that how we can use new emerging technologies, which is combining robotics, AI, and other tools to create a solution which can be more integrated in the society. And one of those solutions can be for healthy and active living. So how to ensure that people are getting monitored, and family members or healthcare professionals are getting alerts on the right time, so that something bad can be avoided. Another thing is that how we can ensure that people who might not be so connected with rest of the society for whatever reason, perhaps for a particular situation or scenario or time, how this kind of technology can serving them and helping them to bridge with rest of the community.
Why do you look sad? Which doctor should I consult first for breast cancer? Primary care physician or OB/GYN.
So here, as you can see, the idea is that how the robot will be able to understand the situation, the mood of the person, and try to engage with the person so that even person can share the concern or the questions, and then the robot or AI agent is able to take right kind of action, or at least to connect with the right kind of people to help the person. So perhaps we are now out of social isolation um, or social distancing in one sense. Uh, but there are obviously very different kind of situations where people feel isolated, and we have to find a way for them to be connected. So the idea is that hopefully one day there will be someone 24/7 for everyone on the planet to better support and assist. Okay, so the next one is that how we can use avatar technologies to again bridge the gap between people. So here the person on the right is using the robot as the avatar, interacting with the person at remote location, doing some medical examination, as well as interacting with the person even through multimodality and facial expression, and also supporting in some task by performing those activities. So this kind of solutions can really bridge the gap and bring people together in one sense or another, and they can be useful in telemedicine, telehealth care, or teleeducation, whatever we can think about. Also, there is this aspect of learning through interaction. Thank you.
Did not get you.
If someone says thank you, you should reply, you are welcome.
Understood. Need to say you are welcome for thank you.
Namaste.
Did not get you.
If I say namaste, you should say namaste.
Understood. Need to say namaste for namaste.
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 Thank you.
You are welcome.
So this is very simple example, but it shows that these agents are able to interact with the people, learn new things, and even use those new things in their behavior. So the bigger question is how this kind of learning can be more useful, and at the same time how they can learn more complex things. And more important question is that how to ensure that the whatever they are learning is good, not creating any harm, fear, surprise, and where is the rule book of good behaviors or good learning. So how to ensure that at technology level as well as at different level where people are trying to teach, or even the agent is simply trying to learn by observing from the scenario and the person. So to summarize, there are interesting needs and challenges which we can solve together on conversational AI side, on generation of multimodal interaction, the management of knowledge, and then how a kind of semi-autonomy be achieved even in the telepresence situation. And perception is also important, and then explainability and privacy and security. I think these are the key things for bigger adaptability and acceptance of these technologies. And also the challenge for us is that all these things should be working in real time, in real life situation with the real user. So we have to even think about the sustainability, and we have organized a workshop on duality of sustainability and application, in the sense that what can be the sustainable societal applications and what can be the societal applications for sustainability. So we will organize another session in this in next year of European Robotics Forum. Hopefully some of you might be able to join it. And as I mentioned, we have to keep collaborating, and there are various ways which we can think about for collaboration, including joint lab projects, joint supervision of PhD master students, internship, transfer of technology, and why not to explore some pilot studies together. So we are open, and let us be in touch for exploring interesting ways to work together. Thanks again, and hope to see you soon again. Bye.
Okay, thank you. Thank Amit. Yeah, the next panelist is a pleasure to introduce to you. We have known each other for a very long time already. I think it's like over 10 years now. I don't know. When we met in Robotics Lab in Freiburg. Mark van Look, he's at Toyota Motor Europe, and maybe you can say some words about yourself.
Yeah, I have to admit I am not a roboticist. So to be honest, I am a physicist who rolled into robotics. Nevertheless, I hope that the work that we're doing can still inspire you to proceed in the open innovation that I was asked to talk about today. Because also from Toyota point of view, open innovation is quite important. And this is also why we are sharing the human support robot as a platform to many universities and institutes, not only in Europe, but actually globally. And this since, I believe 2017, roughly. And yeah, the subtitle here is a little bit the enhanced self-reliance and caregiver support. This is one of the areas where we believe that also our human support robot could be of particular use. Taking one step backwards, if the remote, yes, here we go. Taking one step backwards, so for Toyota, obviously it already started in the 80s with the introduction of industrial robots to do some factory automation, but then it was really around 2004 with, in the rise of the World Expo in Aichi, where we started development more in the direction of humanoid-style robots. The choice there was made to actually develop humanoid robots that did music, because for playing music you need to have really dexterous manipulation, and this is one of the core skills. And then using the core skills that we developed there, we could then announce in 2007 our development plan towards more practical application targets, and this in 4 areas, being manufacturing, personal mobility, nursing, healthcare, and also domestic tasks. This then in turn led to the announcement of some of our robotic solutions like personal mobility, as you can see. And then in 2011, also some healthcare robots, one of which was then also moved forward for commercialization in 2017. So this is our Will Walk platform for recovering from brain stroke. And in between 2015, not on this slide, was also the release of our human support robot. In the back of this is, of course, as we all know, we're living in an aging society where the relative ratio of working population and aging population is shifting quite a lot. With as a result that there will be a 3 times increase in burden on the working population by 2050, according to these numbers from Japan. And actually I came to realize last week that I will be also in the aging population by 2050. So I found it quite confronting, but it is reality. So we better make sure that we prepare for our own old age, basically. Now, when we see this increasing burden for the working generation, then many people always think like the robot will take my job. This is not the case. The way we see it is we can put the robot alongside the working population and somehow keep the ratio under control so that also the working population does not really have this increased burden. And this is also one of the reasons why we like to call our robots partner robots, because they partner together, and in a way it is about augmenting the human, right? Not replacing the human. This is very essential, and maybe it's something that as a robotics community we do not emphasize enough, I think. It also takes away part of the fear that people may have with respect to robots. Then quite lucky, I mean, most people know Toyota as an automotive company, right? And our global vision here is that actually we want to be rewarded with a smile by exceeding the expectation of our customers. And through the original core business, the cars, that was kind of reflected in always building better cars. But we all know automotive market is changing, and that also means that as a company you need to reinvent yourself. So in 2018, our global president, Akio Toyoda, he announced that we're no longer an automotive company. We should transform into a mobility company, which means that we should not only make always better cars, but we should enrich the lives of the communities, because people need more ways of mobility than just a car. And this is not only in the physical mobility, it can also be information mobility. There's a lot of different ways how you can perceive this kind of mobility. Luckily for us, working on robotics is also one of the development areas. So where essentially this support of society via mobility can also go through robots, and that's kind of happy news. And this and kind of the ultimate embodiment of this mobility is the Woven City project, which is currently being built in Japan, in Higachifuchi, at the location of an abandoned Toyota factory. And the Woven City basically has as objective to be an ever-evolving living laboratory, which is totally human-centered. That means that in essence there will be a place for around 3,000 people. Some people live there permanently, living a normal life, but there's also room for guest researchers who develop innovative technology in robotics, in mobility, in biotech, in fuel cell, anything that basically a smart society may need. And this is quite exciting, and when I saw the lab of Professor Beets earlier, this is kind of exactly the same vision that we have, right? So we want to have kind of a real-life situation where people can come to do the implementation and evaluation under realistic or as realistic as possible conditions. And this is perfectly aligned, and I think that's quite nice, to be honest. It's also the only way forward. So practically for us, and especially this is then especially for the robotics part, for the mobility for all, we see that in 4 different areas. On the one hand, you have healthy living and senior life at home with possible mobility solutions, as you see there. As already shown, you have hospital environments with quick recovery, for example, with exoskeletons like the WellWalk. And then more interesting for us, I believe, in facilities and homes, you also have caregiver support, welfare, and self-reliance for the personal life. This self-reliance and personal life would mean that you could enable also elder people to stay independent in their own homes longer, which still kind of gives more like a fulfilling life and a better quality of life. So yeah, I'm not sure if I should show this. Probably, I hope at least you know our human support robot, which has one of the core features that it can pick objects from the floor. So this is one of the big requests from elder people, that they drop something and they cannot pick it up. At the same time, it was specifically designed for the home environment, being compact, safe, reliable, and intuitive. And the objective is also to have the manipulation tasks, even though I heard some complaints yesterday also from Marcus is saying that the gripper could be improved. So, I mean, that's okay. It's open innovation. Getting that feedback means we can move forward. So, happy to hear that. So, as said, it's also an open innovation platform, and actually, as you can see here in Europe, we currently have 14, 15 locations where we have the HSR installed. I did mark only the German ones here. So we have one Bremen. We recently moved with Professor Burgard to Nuremberg, also one HSR. We have in München with Gordon Cheng, in Freiburg with Professor Valada, then in Bonn, both with Sven Beenke's group and at HBRS with Professor Plöger. So there's a few, and actually, and this is something that I also want to say, we're still getting requests for HSRs. Sadly, we're also limited in the amount of HSRs that we can provide. So the key question then is like, how can we still push more forward to this open innovation concept? And when I then saw earlier the presentation of this digital twin, I think this could be one way forward, right? So if you can provide this virtual environment, this digital twin, to different universities, then they can first develop their algorithms there, and then in the last step, when it is kind of validated in simulation, come here to one of the hubs that have the robot and do the final testing, which has two benefits. On the one hand, you can grow your community, and on the other hand, of course, you create additional interaction between different labs. And we cannot do this on our own, so the more we can interact together, the better it is, the more progress we can make. And this is why we strongly believe in this open innovation concept. And we're super happy to see, not only in Bremen, but last week we got the same message in the UK, where you have these co-creation labs, where you have this robotarium in Harriet Watt, where the lab is open for experimentation. And I strongly believe this is the only way forward for robotics as a community to make the progress that is needed to achieve the results in 2050, when I reach the old age, to actually help me get out of the bed and have a good quality of life. I think that was my last slide, so I would like to wrap up.
Thank you, Mark. Thank you. Okay, our next panelist is Gayan Katsuyan from University of Bremen. I'm sorry if I didn't pronounce your name well.
Hi. Yeah, so my name is Gaia, simply. I'm a researcher here at the University of Bremen in Michael's lab, and I am just going to give you a very short overview of our efforts in implementing the open source and open research, open data paradigm in our institute, and kind of talk a little bit about our experiences with this concept. So we are very strongly committed to the open source paradigm, to this concept, and all of our software is open source. So here is the GitHub organization of our research lab, and you can see we have 149 different repositories on it. So 149 different software packages. And in addition, each of our main software components that you also saw running on the robot in the apartment lab, they have their own organizations and their own repositories. And yeah, you can see that some of the repositories are more used, some are less used by the community. But yes, for each of our software components, we actually have websites. The main components, so for example, the CREM, GISCARD, and NOROP are our plan executive, our motion planner, our knowledge representation system, and we have other websites for the other components with like installation instructions, with documentations, links to papers, and of course, very importantly, the tutorials. We do rigorously update and maintain our tutorials such that at least the beginner tutorials are kind of easily used, and such that people can download the software, install it, and at least run the beginner tutorials. And of course, this is taking us a lot of effort as PhD students to do this maintenance, to update the documentation. And it is generally not very valued by, like in a PhD work, in a doctoral dissertation, this kind of work is not really acknowledged. But we do consider it very important and very also valuable for us, because first, it gives a paper, at least in my eyes, more credibility if it is supported by software and if actually people can download it and use it. You also, if people use your software, you also get free citations, so and you also get more kind of dissemination by associating yourself with the software. And we also find that this whole ROS community, which is open source, and the robotics software packages that are provided to us that we use for free are a huge help, and we kind of try to also give back to the community by doing that. Because a lot of people just use whatever was provided and whatever people put effort into making usable and kind of don't give back, and we are trying to put a little bit of our also contribution there. And actually you get also work done for free for you if you put your software up. This is, for example, the ROS integration repository that is the bridge between the Unreal Engine and the ROS ecosystem that we implemented. And we can see that it has 70 pull requests merged into the repository, and more than 90% of these contributions are from people that we have never seen. They are just random people from the internet, and they are providing these contributions, and we are merging them, and kind of the software lives on, even though we, in our lab, we are not using this software package anymore, but the community keeps providing updates, and we only need to merge and take a look and take into our software their contributions, and this is really awesome. Yes, and we also, of course, have the, we also don't put only the software up, but we also provide the data, and this is kind of the NIM Hub organization, and you can already see that there are a lot of data packages with robot experience data that we have collected, and we are collecting more, and with the EASE project, this is kind of one of the main results of the project, so there will be really hundreds of data collections. And with the OpenEase webpage that anybody can log in and register with a couple of clicks, you can access the data and yeah, open it on the OpenEase website and query it and see what's inside. Yes, and that's basically what I had to say.
Thank you very much. Okay, and our last panelist is Klaus Eichel, also from the University of Bremen. And I'm looking forward to your presentation.
Hi, so my name is Klaus Eichel. I did my PhD here in Bremen, actually right next door. I'm probably the one here in the room with the least knowledge on robotics. So I'm a physicist by training, and I did my PhD in medical imaging. But I was invited for this session to talk a little bit about open research, open source, and open data. And so even though I'm the last one, I'm pretty happy that nobody gave any definition of it. So I will do that. If I can forward, where is the... there. So what is open research? So open research is, of course, openness throughout the whole research cycle. It involves collaborative work, open access, so publishing your results open, and open data. And of course, you all know that, but I think it's very important to keep that in mind with everything or with every step you do in your work. In particular, if you try to publish something open, you should start bothering about it rather early. Why should you do open research? Or you as a scientist or even somebody from a company, why should you bother about open research? Well, it's clear that we have a lot of limitations. So the funding is limited, the labs are limited, time is limited, and I think nowadays even scientists are limited. So it's very difficult to find enough people to work in your projects. So you should bother about not wasting too much work by keeping it in your lab and not having it openly available to others. Open research is also research that has much higher impact, so fast impact, because it builds upon existing knowledge, and so you can pick up knowledge, and of course your knowledge will be used by others. Another point is that it's fair, and it involves the public engagement, or it addresses public engagement, because much money we get is public money. And I think it's more than fair to communicate results and to justify where the public money is spent for. And I think open research is a good vehicle to do this. Open research also enables much more interdisciplinary conversation. So many of the let's say global challenges are of course too big to solve in one discipline. Looking here in the labs, it's of course the aging population. I mean, probably if it's only a robot lab addressing this, you will not come very far. You need other disciplines, you need the healthcare disciplines, you need the disciplines that do the engineering, but you also will need disciplines that help you to bring these things into product in the end. And last but not least, open research will give you a direct benefit for yourself, because it will, very likely at least, increase the citation rate and usage rate of your research. So open source is, in my opinion, of course, open source code. And so it's, of course, code that's freely available that you can modify and redistribute. And now I have a question to you. Does anybody know what that is, this diagram? It's done with free software, so it's open source code. And it's a software that's called Root. Any guesses? That's a Nobel Prize. It's a Higgs boson. It was found with a Root software that is developed by the CERN consortia, so in Switzerland. And actually, I needed to smile a little bit. So the Nobel Prize was given in 2013, and during my master's in 2010, I also worked with this Root software, and I didn't get that plot exactly, but I got at least the same style in my plots. So the last point here in this title of the session is the open research data, open data. And well, open data is of course data that is freely available, that you can share, integrate, and reuse. And for open data, there exists a so-called FAIR principle. So open data should be findable, accessible, interoperable, and reusable. And that's important to think it all the way through. So before you acquire data, you should think about this. Because in the end, the important thing is that somebody can reuse the data, either in science, in public, or in an industry. And even though I work for the UBRIM Research Alliance, I also have a second affiliation with a small medium enterprise in medical imaging. And I can say for the small medium enterprises, open data that can be used is very crucial, because data has such a high value nowadays. If you don't have access, you cannot do your business. That's the one thing, but you cannot provide solutions in the fields you work in. One side note here on the very right, the colleagues from the UBRIM Research Alliance and the University of Bremen, they published 2 years ago a white paper on how to establish a collaborative data management tool here in Bremen. So if you're a researcher here in Bremen, I think it's worth to have a look on that. Last but not least, so how to start with open research? So just start. I think that's totally easy. Just promote interdisciplinary work, promote exchange, so talk to each other, participate in challenges. I think in particular yesterday we have talked about this a lot. So I think in robotics it's even more common, but also in other fields. Challenges are really a good tool to, in a friendly way, to have competitions and tackle very specific and well-defined problems and move fields forward. And then of course, use existing services. So I just picked a few logos that I quickly found, but I think if you start looking for open science and or open research here in Bremen or nationally or internationally, you will find many tasks that are solved and many helping hands that will guide you through this. And in the end, it will totally ease your work. So these were my thoughts about it, and now I think it's a good starting point for the discussion.
Yeah, thank you very much, Klaus. That's a very interesting discussion. It's actually would have been my first question also to any of you. What is your definition of open? Actually, I wanted to start this discussion with that question. Maybe the other two can also say something about what you think what open is and what it means for you. And the second question would have been, what are the benefits and where are maybe limitations? Maybe, I don't know. Yes, please start.
Yeah, so, well, obviously open source is just putting your the source code up for everyone to share, but of course it also involves, as I mentioned, like work that goes around it, because a lot of the times you download, like you read a paper and it points to a source code and then you download it and you cannot use it at all, or it's a version that is very outdated and things like that. So for me, when you are providing software for other people to use, you should also put a little bit of effort to make it accessible. And but yes, and then you have, for example, as a researcher, a paper deadline, and you're really busy working on something, and then somebody creates an issue and says, "Oh, I just downloaded your software, and there is this bug, and it's the thing doesn't work for me, and please fix it right now." And of course, it is stressful. So that's kind of one of the main limitations for me, that of course it takes time, and the only thing that you're kind of getting out of it is a thank you from this person, yes, but then on the other hand, of course, as I mentioned, like it has a lot of advantages as well.
Thank you. So maybe one just question on that. You said everyone. Are you really meaning everyone in the whole world that can use your code? Do you really think that's the aim? Don't see any problems in that?
Well, yes, we had one little incident where people from the military had some interest in tiny. It was a very unrelated to the military software piece. It was also just bridging two parts of a simulator, and you would have never thought about this, but yes, and they had this interest. So of course you need to think about this when you are developing the software.
Or someone making a lot of money out of your idea? I mean...
Yes. On the other hand, if it depends on the license that you choose. So for many of our software, we have a license that allows you to reuse it, but you have to keep it open. And every contribution that you make as an industrial company using this software, you have to also kind of give it back. And yes, you can make money with it, but at least you have to keep this software alive and available for other people. But on the other hand, you can choose a license that allows anybody to use it, and that will simplify the question of transferring from research to industry, of making your own startup with this software. So there is also that kind of advantage.
Maybe Mark, if you want to say something.
Yeah, I think that there's one key thing. Open does not mean free, and I think this is a very essential principle. And the key idea is that we want to make progress as a society as quickly as possible. And what I see from company perspective is that if you have open innovation, open research, then you can see where the field is going much quicker. You can do early on some investigation, some trials, and say, this is actually quite close to what I want, or I still see like a small gap there. But if we do something together, then actually we can cross that gap and reach that target. So we had somebody mentioned yesterday as well, like I think it was you, by the way. Sorry, pointing is not polite, but you say it's through the interaction of smart people that we create innovation these days. And I think the sharing of code, of data, and so on is one way to create this innovation, and that's what we actually need to have here. Are there risks? I think so, and one example that came to mind immediately is, and it's especially for academia important, if you have some cool research, you publish a paper, your best paper award, ICRA 23, and you say, I want to go for open innovation, and I publish all the code online. Everybody can see, everybody can tag along, find this small improvement point, and then actually overtake you in your own work. And this is a little bit, it's a possibility. I don't think you make yourself popular, but you can get publications in that direction. Sadly, that also happens. There's stories in there as well. Yeah, maybe one thing, open data, I think, is a little bit more tricky these days for multiple reasons. On the one hand, you have GDPR, which kind of ties your hands in what you can actually share openly, especially if it's related to people. Secondly, data is money, and it's your competitive edge that you have. So sharing data sometimes a little more tricky. We have shared some of our data in the past, but then of course you want to keep some validation data for yourself so that you can see how other people train their system, and then you can cross-validate on some data that you kept for yourself to see if it's not overfitting in any way. These are some answers, I hope, to the question.
Yeah, thank you. Thanks. Klaus, maybe?
I have also some comments. Maybe, so I have these two glasses. So this glasses from academia, but also for now 1 year from a small company. And I think in general, yeah, of course you can always say companies make the money with it, but on the other hand, you won't do it. That's the point. So you actually, it's only something that you theoretically lose, because normally you won't spin off, or at least I would say in the most of the times. Well, maybe in some disciplines. And if you want to do that, you can think about this first before you decide. So you can prepare to have it all open, but then you can still not do it if you want to spin off, or you can use you couldn't put patents in place, so that it is open, but still you patent your idea, so that it's not that this property stays yours. I think there are ways to do it. Of course, it costs a lot of money to place a patent or to file a patent. But on the other hand, I think really we, like in academia, you are publicly funded. So there's the right of the public to receive that back, kind of thing. So it's not your decision that a company makes or does not make money with it. It's not your decision. I think that's an important point. And I think concerning this challenges or this, I mean, of course, it's a race also in the scientific community. So who wins which award or publishes which paper? So I think you can also be careful in open research. So open code doesn't have to be that you place everything open, but it is if you use open platforms and contribute to them and use them. So you can keep maybe your little tiny secrets for a while on your own, but then you can open them up. I think you can solve these problems, and yeah, I think that's important.
Okay. Any other questions from the audience? Maybe I just want to follow up on that, the definition of public. You say it's public funded, so it should be also coming back to the public, but who is that public, right? So that's the question, right? If it's the German state, of course, but it's then not open just for the German state, right? So if we, with our tax money, pay this, the whole world can have it, right? Is that what we want? I mean, it's not exactly that easy, I would say, with public, right? So the definition of public is difficult. What do you think about that?
Yeah, that's true. I think there are, on one hand, you can place license concepts there that you restrict this. On the other hand, sometimes it's really difficult to track back a license, or if it is misused or so. But I mean, if you think about the good in in public, or the good in countries and in politics, then it should be equaled out in the end. So I mean, of course, not every country has the same budget on research, but the richer countries have, and so they also help not so rich countries to develop quicker. And I mean, it's not only that others, let's say in the US, use our code, it's also that we use the code from public money in the US. So I think in the end it could even out, maybe. But of course, it's all, I mean, if somebody, the question is, can you avoid I mean, if you close everything, then you can avoid that somebody uses it and that there is any harm with your work, and that anybody will use it to harm somebody. But I think as soon as you open it, actually already if you publish a paper, it could be like that. And yeah, I think always looking on the worst scenario doesn't bring the society forward.
That's right. Yeah, but one can think of something in between, right? In between of complete close and complete open,
that's,
right? Something where
but that's if you have license, or if you use a platform and not like contribute to a platform. So that also could maybe lower the burden on maintaining software if you use, I mean, one example is root software. I know it's totally specific. It's only for particle physicists. But I think it's run by all major experiments in the world. That are experiments with billions of euros in budget. And they have at one point decided to use it. And of course, I know it's totally specific. But on the other hand, everybody contributes, and still they discover things, and they move forward with their specific research. So it is an example how it can work.
Okay, Jürgen?
I actually, so over the past... Okay. So over the past 20 years, I think a lot of things have already happened, right? 20 years ago or so, there was not too much open source code and definitely no open source data sets and so on. But in the meantime, I think definitely at CVPR, there's probably not a single paper anymore that doesn't have code or a data set or both, right? Yeah. So maybe it's a little bit different in robotics because the robotic platforms are not so easily shareable. But still, I'm wondering, maybe, at least certain domains already have succeeded. So I'm wondering, how much is still left open, or what is, I'm curious, what is your gut feeling for where are we at the moment in terms of open research, open source, and so on?
Who wants to answer?
Yeah, I wanted to kind of address this a little bit, that you compare the different research communities, because I think if we're just talking about software, like a little program that somebody did that they did on their own, or maybe with two people, and then they don't want to share it because they want to make money with it, it's understandable. But in robotics, it's just so tough, as Michael also mentioned, and he keeps mentioning every day, and yesterday he also mentioned that there is no way that one research lab can, come up with a mobile manipulation platform that can do something in your house if we just do it on our own. So it is like without ROS and without the PR2 platform, which we also got for free, as well, at the beginning with the beta program, this wouldn't be possible. So if we don't share as a community our software, robotics will not move forward. It's just kind of, for some people it's a choice, but for this community, I think you really have to do it, because motion planning, you use OMPL. Of course, we have our own software framework for everything, for perception, for motion planning, for plan executives, but we still use a lot of components that were provided to us from other people. And if they didn't exist, we wouldn't be able to even place a cup on a table and pour a little bit into a bowl. So this is really kind of not a question. And but of course, yes, nowadays we see a lot of papers that also share code. The problem with the robotics community, again, is that you cannot reproduce results so easily. Maybe with the perception community, you can just download the data set, run the algorithm, just your computer, and
Reproducibility is a different topic, right? It's not about open research or open data, right? Then it's how easy is it for someone else to reproduce your results? Having all the data, having all the code.
But even if like you have the code, you need to be able to execute it, and if it's code that is supposed to run on a physical robot, then then it's much more difficult. But on the other hand, I also think that especially robotics researchers, they have like this skill that they acquire over time to, get something that doesn't run, or just get a piece out that they think, oh, this is a great algorithm just by looking at the code. And then from that point of view, I think it's really valuable that people start to share their code. And you're reviewing a paper, you go there, open the source code, and you actually see if they really, have this ontology that they are talking about or not. And then you see that they actually do, and then it's much more credible paper for me right away.
Other opinions on that?
Yeah, I wanted to say something. Are we there yet with open innovation? I think no. In the sense, if I look at, I showed the timeline, right? So 2004, in Toyota, we started with the core functions. Then around 2010, we had somehow decent applications. I think we're still in that stage that we can get things to work, but we don't get to the level where we make what people want and need. My feeling is, as roboticists, we are still hallucinating about what people really need. And this is the point where open innovation should also open up to other disciplines, sociology, ethics. And it is only when we really open up the innovation to those areas that we can try to understand what people really need, and that we can start tackling the actual issues. For example, I mentioned yesterday, I think to Rudy, a typical example is the pocket calculator, right? We can make a pocket calculator. The result is people will lose the possibility to calculate by heart, right? The same with robots. Probably we can make a robot do anything we want, but do we also want to provide any function to the user? Because every function you provide to a user may be a skill that you take away. It is something that, as roboticists, we do not consider yet so much. But we should be aware that this, in the future, should also be one of the challenges that we need to address if we really want to have responsible robotics. And I think their open innovation will become more and more important, especially with respect to social sciences.
Okay, Klaus? Maybe first and then, sorry, yeah.
I have a short comment on this because, as I said, I have no idea about robotics. But what are the regulations you have, and how can you bring? I mean, a robot in a factory is easy is the wrong word, but it's a fenced system. It's well controlled kind of thing. So you have in the worst case you just put up boundaries that the robot cannot kill somebody. But in the daily environment, I mean, it's a question also of trust and of regulations. And coming from the medical field, that's really, once you have a system ready and you think as an engineer, it is ready, and also maybe as a company, then the regulations hit in. And I think it's very important. And I think open research and open data and openness in general can really help to get the community or get the public with the development. So keeps the pace up also in the public, so that acceptance is there. I mean, of course, we all have have smartphones by now, and maybe nobody bothers anymore about is there a mic running all the time or not. Maybe 10 years ago this was different, but I think robots in everyday activities, they have really a severe impact on your privacy and on your life. And I don't know how the regulations are at the moment. Probably there are some, not so many, and it's just not allowed, or it's your own risk. But at one point, I think once you want to have it in the like on the larger scale, you need to think about this. And I think openness throughout the whole development scientific cycle is very important.
Okay, there was one question.
Yes, I think we need to look at the next step. I think we are reaching towards the next step of the evolution of open software, where there is a lot of information now. And there is like a lot of data sets, repositories, and now the problem is filtering. Because then we depend on the resources we have on the lab. For robots, we don't have sometimes GPU or all these computational power stuff, right? So we cannot use some other resources. And then some are deprecated because then you need specific libraries. So when a new student comes in and tries a different software, I mean, you were mentioning 147 something repositories. What is happening with the old ones? Are you going to delete them, or do you have like a guideline for people looking into the more specific ones? I think we need to start thinking about this, right?
Right. Yes. Yeah. In answer on this.
Yeah. So for our many repositories, we will probably delete those that are really not used anymore eventually, yes. But I also don't think that people actually stumble upon them so much. But for the ones that are actually used, I think at this point with the filtering, it's very, very correct. There is too much data. Eventually, there will be just too much to choose from, and too much software alternatives to choose from. And this is, I think, the point where the ease of use is really, really important. That you should put the effort into making your software usable and your data usable. You should explain what it is. You should really make it kind of very clear yeah, to put your message across. And in that case, even if your software is maybe not extremely powerful in comparison to some other persons, but if it's simple and you can install it and it's kind of clear, then I think people will still prefer to use that.
Mark?
Yeah, I wanted to add something. We internally have the habit of doing all our development in Docker containers. I don't think it's common practice yet to do the open source in Docker containers, but at least it allows also, even if the code may be a little bit older, to still be able to compile and run the system and kind of have some of the library conflicts that you may have to avoid that. But this then goes again more in the direction of software engineering and setting up your continuous integration workflow and so on, which was also something that you mentioned earlier, that maybe this is also a little bit of a focus point, and that maybe more standardized tools and more easy to use setups probably would help a lot of researchers as well.
Klaus?
I would have a comment on deleting repositories or deleting existing code. I mean, I would totally agree if you have a new code and it's better and it's well written, that you could delete your old one. But on the other hand, I think there is no need to. I mean, this will grow. So the amount of code will grow, the amount of knowledge will grow. But I think that's the same or a similar discussion as with publications. So when you do the classic publications in a journal, they have still sometimes limited numbers of papers they accept for any volume or so, and there is an editor's choice in the end. And actually, I don't see a reason why that is. So I have one publication at with +1, and actually I have to say it was not my first choice. So I first used the classical journal for this field, and it was rejected. So I then resubmitted, and it was again rejected. And the game everybody knows. And then I submitted it to +1. And actually, this review process was even harder. So they didn't reject because it didn't fit to the scope of the volume or so, because they don't have this criteria. They just looked on, like, is it scientifically correct? Do we have open data? So that was the first time actually I had to provide this publicly. And I think that was actually, it was a really tough review process. It took long, but in the end it was successful. And then, I mean, the decision is to the readers. I mean, it's more or less no cost to have that online. And the citation rate in the end says, so it's a kind of a filter by experts then that validates, and I think that's also true for code. And if you delete it, maybe in some future years, somebody would at least need a piece of it and could find it potentially. Yeah.
Are there opinions on that, on the public? Yeah, I'll give you the microphone.
So I just wanted to reinforce that suggestion that we don't delete. Once you put something out in the public domain, because I might write a paper which cites that, and then if you delete that, then my paper then becomes out of date. And also, I mean, the University of Leeds has a repository where we can put these data sets in with DOIs, and that's then even more protection against changes in URLs, which means they become broken. So I strongly encourage that as well.
Thank you. Yeah. Do you have a mic? Just hand it over to.
I mean, my personal answer with respect to the code is it's clear, it depends. I know papers where the pseudocode and the theory is so awful that only by looking at the code I could understand what they really did. So the results were so amazing that I was like, okay, the paper is written awfully, but the results are great. I really want to know what happened there. So I looked at the code, which for me is painful. So when I have an excellently written paper where the algorithm, the theory, the formalism is very clearly laid out, I don't want the code. So my experience is that in a worst case scenario, you have then a student who invests 10 hours of having the right version of Ubuntu with the right version of ROS, with the right version of whatever to get this little piece of code running, while in 1 hour, this student could have re-implemented it and understood it, which is also a great feature, that sometimes when you re-implement, you have a deep understanding, you might even improve things. So it's a very clear, it depends. It's a very big benefit to have the code, but the quality of the code, the quality of the documentation, the quality of the theory behind it, they're all interconnected. So there is never a simple answer to it.
Thank you very much. That's a very good last final words, I think. I think we have to close up. So yeah, thank you very much for the lively discussion. Thanks to the panelists, and I'll hand over to Michael.
Yeah, just a couple of final words. So I think it was kind of tremendous these last 2 days, right? And I think I would just like to again thank the organizers, right? And the people who did the technical infrastructure, and also the doctoral students who actually made that all work, right? I think it was a tremendous effort. And I think in times where we have so many people sick and calling in and have to kind of organize that in such an agile way, and I think we did a lot of improvement, kind of improvisations, right? But I don't think that it actually showed off in the quality of the contributions, right? And I think that was just amazing. Kind of, we tried to make a very short summary of that second day, because I think it's kind of was very valuable in the different dimensions. And finally, I would like to thank all of you for coming and actually making that possible, so that we could meet all together. And I hope that we can keep the spirit of these days, right, and maybe kind of inject somewhat in European and kind of live it in that kind of context. Thanks a lot.